अब कुछ ही क्षण में हमारे बीच हमारे माननीय मंत्री श्री आ रहे हैं, तो हम सब उनका तालियों से अभिवादन करते हैं।
Shri Rishikesh Bhai Patel, Mananiya Cabinet Minister, Energy and Petrochemical Department of Gujarat. Sir, we heartily welcomes to you. I would like to request our mentors, our moderators, Sri S.K. Suni Sir, Senior Advisor CEA, please come up on the stage and have a seat. Sri Rajiv Porwal Sir, Director, System Operation, Grid India, NLDC, Sri A. Ballan Sir, Member of CEA Planning, Sri Dr. Zakir Hussain Rather Sir, Professor IIT Mumbai. I would also request Sri Kailash Kumar Gupta Sir, Chief Operating Officer, CTUIL, and Sri PC Garg Sir, Principal Advisor, NSEFI, former COO, CTUIL. We heartily welcomes you all.
નમસ્કાર. ભારતના ગ્રોથ એન્જિન તરીકે દેશમાં આગેવાની કરતા ગુજરાત રાજ્યની વિકાસ યાત્રાનો પ્રારંભ કરાવનાર તત્કાલીન મુખ્યમંત્રી અને હાલના વિકસિત ભારતના પ્રણેતા એવા આદરણીય વડાપ્રધાન શ્રી નરેન્દ્રભાઈ મોદી સાહેબના દ્રષ્ટિવંત નેતૃત્વ હેઠળ આપણો દેશ વિકસિત ભારત 2047ના સંકલ્પ સાથે આત્મનિર્ભરતા, ઇનોવેશન અને સસ્ટેનેબલ ડેવલપમેન્ટ તરફ આગળ વધી રહ્યું છે. ગુજરાતની ધરતી હંમેશા સાહસ, ઉદ્યોગ અને પ્રગતિની પ્રેરણા રહી છે. વાઇબ્રન્ટ ગુજરાત આ જ સ્પિરિટને વિશ્વ સમક્ષ રજૂ કરે છે. વિકસિત ભારતનો મુખ્ય હેતુ ભારતને આર્થિક સમૃદ્ધિ, સામાજિક પ્રગતિ, પર્યાવરણીય ટકાઉપણું અને અસરકારક શાસન દ્વારા વિકસિત રાષ્ટ્ર તરીકે પરાવર્તિત કરવાનો છે. 2047 સુધી ભારતની વીજળી વ્યવસ્થા ગ્રીન, સ્માર્ટ અને આત્મનિર્ભર બનાવવાની છે. આ પરિવર્તન માત્ર ઉર્જા ક્ષેત્રે નહીં, પરંતુ સમગ્ર અર્થતંત્ર અને સમાજથી ગામ, ગામથી શહેર, શહેરથી રાજ્ય, રાજ્યથી સમગ્ર દેશને આગળ ધપાવશે. તો ચાલો આ મંચ પરથી વિકાસના નવા અધ્યાયની શરૂઆત કરીએ. સાથે મળીને ઉજ્જવળ ભવિષ્યના સપના સાકાર કરીએ.
Respected dignitaries, Honorable Minister Sir, moderators, industrial leaders, experts, and delegates, ladies and gentlemen. Good morning to all of you. I am Danisha Bhuva from JETCO. It's my privilege to welcome you to Surat for this session on 2047 Green Energy Rich Grid System Planning and Integration. We stand a defining moment. As the world moves towards decarbonization, India is the leading with the Viksit Bharat at 2047 vision to power a $20-30 trillion economy on a self-reliant green energy backbone. Gujarat is defining this transition with the 30 gigawatt Kutch Hybrid Park and Dholera Solar Park. We target 190 gigawatt RE by 2047 and aim to India's green hydrogen hub for a heavy industries. We know that RE needs a strong grid. Today, we focus on the backbone, smart grid, future-ready transmission system to integrate solar, wind, hydrogen, and storage while ensuring 24/7 reliable power. Surat embodies this vision, powering textile MSME with green energy and emerging a solar manufacturing hub. In next 90 minutes, we will deliberate on a grid sustainability solution and infrastructure expansion to enable 200 gigawatt non-fossil capacity in Gujarat by 2047.
This is a call to collaboration. The roadmaps we shape here will be the blueprint for a resilient net zero power sector. I thank the Honorable Chief Minister of Gujarat and MNRE and all of you for shaping India's green future. Welcome once again to the Surat. Let us collaborate, innovative, and energize Vikshit Bharat 2047.
Let's start our session with a small prayer. Please join us. वक्रतुण्ड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा सर्वकार्येषु सर्वदा.
As a token of our appreciation, we are delighted to present our dignitaries with a copy of a book, Why Bharat Matters, authored by Sri S. Jaisankar, Honorable Foreign Minister, Government of India. This thought-provoking work explored India's unique strength and its involving role in shaping the global narratives, offering valuable insight into the country's foreign policy, economic growth, and cultural heritage, and a vision for the future.
Now, I would like to request our Honorable Minister, Shri Rishikesh Bhai Patel, Mananiya Cabinet Minister, Energy and Petrochemical Department of Gujarat. Please, sir, give us a keynote.
મંચ ઉપર ઉપસ્થિત સર્વે તજજ્ઞો અને સાથે આરી અને ઇન્ટિગ્રેશન આ બંને વિષયો ઉપર જેમ જેમ હવે ચેલેન્જીસ વધતા જાય છે, ઉત્પાદન વધતું જાય છે, એની સાથે પહોંચાડવાની પણ એક ખૂબ મોટી ચેલેન્જ આપણા સમક્ષ અત્યારે ઉપસ્થિત થઈ રહી છે. સોલર અને વિન્ડ અને હવે ન્યુક્લિયર એનર્જી પણ, ક્લિયર એનર્જી, ક્લીન એનર્જી માટે પણ હવે કેન્દ્ર સરકારે શાંતિ બિલ પ્રસ્તાવ દ્વારા સમગ્ર દેશની અંદર વધુમાં વધુ ક્લીન એનર્જીનું ઉત્પાદન થાય, લોકો સુધી પહોંચે અને 2047 સુધીમાં જે રીતે ઇન્ડસ્ટ્રીયલ વ્યાપ આપણો વધી રહ્યો છે, કદાચ 2003થી તે આ 2026 સુધીમાં ગુજરાતને જો વીજ ઉત્પાદન છે અને વીજ ઉત્પાદન સાથે જે લોકો વાપરવાવાળા છે એનો સરેરાશ રેશિયો આખા દેશની અંદર વધી રહ્યો છે. ઉત્પાદન આપણે વધારી રહ્યા છીએ, ફોસિલમાંથી નોન ફોસિલ ઉપર જવાનો પ્રયત્ન ગુજરાતે શરૂ કર્યો છે, આખા દેશે પણ એને સ્વીકાર્યો છે. પરંતુ સાથે ઊભી થનારી ચેલેન્જો અને ચેલેન્જોને હલ કરવા માટેનો વિષય અને એના ઉપર એક્સપર્ટ ઓપિનિયન અને આપ સર્વ તરફથી જે પણ કોઈ ઓપિનિયન્સ મળશે, જે નોટ તૈયાર થાય તો ગુજરાત સરકારે એમાં વધુમાં વધુ કામ કરી અને કેવી રીતે સરળતાથી વીજળીનું વહન કરી અને લોકો સુધી, ઇન્ડસ્ટ્રી સુધી આપણે પહોંચાડી શકીએ, એના માટેના સેમિનારમાં આપ સૌને કંઈથી ફ્રૂટફુલ અને ગુજરાતના વિકાસ માટે ખૂબ સારી એવી તકો હવે ઉપલબ્ધ થઈ છે. અને ગુજરાત એ દેશમાં 47ના વિઝનને ધ્યાનમાં રાખી આદરણીય પ્રધાનમંત્રી મોદી સાહેબ 2003થી શરૂઆત કરીને 2026 સુધીમાં જે એક નાની શરૂઆત વાઇબ્રન્ટની કરી, આજે વૈશ્વિક ફલક ઉપર વિવિધ વિકસિત દેશો સાથે પણ આપણે સાથે મળી અને દેશને આગળ વધારવા માટેનું જે પ્રયત્ન અત્યારે થઈ રહ્યા છે અને ચોક્કસ 2047 પહેલાં ગોલને એચીવ કરી શકાય, પહોંચી શકાય, એના માટે આપણા વિદ્વાન તજજ્ઞો દ્વારા અને કેટલીય હસ્તીઓ આપણા દેશમાં છે, કંઈ આપણને નવું આપી શકે, પરંતુ એમને પ્લેટફોર્મ આપી અને પ્લેટફોર્મ આપ્યા પછી એની થોટ પ્રોસેસને એ અમલમાં મૂકવાવાળી વાત એ હવે હું માનું છું કે બહુ સપોર્ટિંગ આસિસ્ટિંગ સરકાર આસિસ્ટિંગ પબ્લિક, ગુજરાત જેવું વાતાવરણ ક્યાંય આખા દેશની અંદર, પરંતુ ધીમે ધીમે ગુજરાતનું અનુકરણ કરી બીજા રાજ્યો પણ, ત્યાંની પ્રજા, ત્યાંની સરકારો પોતાના વિકાસ માટે ખૂબ હવે પ્રયત્નશીલ છે. તો ગુજરાતે હંમેશા નંબર 1 રહ્યું છે અને નંબર 1 રહેવા માટેનો પ્રયત્ન, નંબર ગેમનો કોઈ પ્રશ્ન નથી, પરંતુ હંમેશા જ્યાં કોમ્પિટિશન હોય છે ત્યાં કોમ્પિટિશનની અંદર હેલ્ધી કોમ્પિટિશન, અને હેલ્ધી કોમ્પિટિશનમાં ગુજરાતે કરેલી શરૂઆત દેશના તમામ રાજ્યોએ સ્વીકારી છે અને તમામ રાજ્યો હવે નવી દિશા તરફ ઉર્જા, અને હવે અત્યારે હાલની પરિસ્થિતિમાં જે પ્રકારની ક્રાઇસિસ ઊભી થઈ છે, કોવિડ પછી સતત કોવિડ, રશિયા યુક્રેન, અત્યારે ગલ્ફ કન્ટ્રીની અંદર જે પ્રકારની માહોલ અને પરિસ્થિતિ છે, આવતા સમયમાં ઉર્જાના વિકલ્પો આપણે શોધવા જ રહ્યા, અને એ શોધી શકીશું તો જ સર્વાઈવ થવાનું પણ, કારણ કે હંમેશા કોઈના ઉપર નિર્ભર રહેવું એ આપણા માટે ખૂબ અઘરો વિષય બનવાનો છે. ત્યારે સ્વનિર્ભર બનવા માટે આપણે ક્લીન એનર્જી તરફ વળી રહ્યા છીએ, અને વળવા માટે ઘણા બધા એફર્ટ્સ, પ્રયત્નો, અને સાથે વન નેશન વન ગ્રીડની વાત છે. ઘણા બધા ચેલેન્જીસ ધરતી ઉપર પણ આવે છે, જમીન ઉપર પણ આવી રહ્યા છે. એ તમામને હલ કરી અને ફરીથી એક વખત ક્લીન અને ગ્રીન એનર્જીમાં આપણે સૌએ આગળ વધવાનું છે, પણ ઇન્ટિગ્રેશન માટે એને વીજળીનું વહન કરી ઓછામાં ઓછી તકલીફ, મલ્ટી ડાયમેન્શનલ સર્કિટ્સ, કદાચ પહેલાં તો આ વિષય બહુ આપણા દેશમાં નહોતો, પરંતુ ચાઇનાની અંદર એક જ પોલ ઉપર 7 ને 8 સર્કિટો લાગી અને વીજળીનું વહન થતું હોય. ત્યારે આપણે પણ આ પ્રયત્નોની દિશામાં આગળ વધી રહ્યા છીએ. હજુ ખૂબ આગળ વધવાની જરૂર છે. ચોક્કસ આપણે તજજ્ઞોનો, વક્તાઓનો લાભ લઈ અને આમાં પણ આપણે આપણું કોન્ટ્રીબ્યુશન કેવી રીતે આપી શકીએ એ માટેનો પ્રયત્ન આપણે સૌ કરીએ. આભાર, ધન્યવાદ.
Thank you so much, sir, for your enlightening thoughts. We will definitely implement the same. Now, we are delighted to present our dignitaries with copy of book Why Bharat Matters, authored by Sri SH11, our Honorable Foreign Minister, Government of Gujarat. Now I request Sri A.B. Rathod, sir, Chief Engineer, STU and SLDC, Gujarat Energy Transmission Corporation Limited, to kindly welcome our moderator, Sri S.K. Suni, sir, Senior Advisor, CEA. He is a prominent Indian power sector expert, policy advisor with extensive experience in a grid operation and electricity markets. He is widely regarded as a key architect of India's moderate power system operations. He is a contributed to a development of electricity market, open access framework and regulatory system in India.
Once again, I request Sri A.B. Rathod, sir, to welcome our moderator, Sri Rajiv Porwal, sir, Director System Operation, Grid India NLDC. A seasoned grid operation expert playing a critical role in ensuring the reliability, security, and efficiency of India's national electricity grid with deep expertise spanning system operation and market mechanism and grid integration. He is associated with implementation of grid code, availability-based tariff, deviation settlement mechanism, and open access framework in India's power sector.
I again requested Sri A.B. Rathod, sir, for welcoming Mr. A. Balan, sir, member, CEA Planning. He is a key play role in shaping India's electricity sector strategy through the planning, forecasting, and policy advisory at national level, supporting sustainable growth and efficient resource utilization in a power system. Coordinate with the central state utilities and agencies, the power sector strategies, research and development, and monitoring the fuel supply and the project appreciation.
Moving towards next, again I request Sri A.B. Rathod, sir, to welcome our Dr. Zakir Hussein Rathod, Professor, IIT Mumbai. Please welcome, sir. He has done PhD in electrical engineering, power system from Aalborg University, Denmark, and working as professor at IIT Bombay since 2018. He leads the Grid Integration Laboratory (GIL) at IIT Bombay, focusing on sustainable energy system and modern grid challenges. Grid integration of renewable energy, wind and solar, wide area monitoring, protection and control, WAMS and WAPAC.
Again, I would like to request Sri A.B. Rathod sir, please welcome our moderator Sri Kailash Kumar Gupta sir, Chief Operating Officer, CTUIL. He is a power sector professional with a deep expertise in transmission planning, project execution, and operational management, playing a key role in strengthening India's national electricity transmission network. Oversight of the project implementation, engineering, and operational function, supporting the integrated of renewable energy and expansion of a grid infrastructure.
Once again, I request Sri A.B. Rathod sir to welcome our moderator, Sri P.C. Garg, Principal Advisor, NSEFI, former COO, CTUIL. Sri P.C. Garg is Senior Power Sector Professional with over 37 years of experience across transmission planning, grid operations, policy advisory, and renewable energy integration. He has served as Chief Operating Officer at Central Transmission Utility of India and presently serves as Principal Advisor to the National Solar Energy Federation of India. Thank you so much all for present here.
I would like to request A.B. Rathod sir, please welcome our Honorable Minister Rishikesh Bhai Patel sir, Energy and Petrochemical Department, Gujarat, with a memento of our book. Once again, I welcome sir. Thank you so much, sir. With great pride and respect, now I invite Sri A.B. Rathod sir to set the tone of the session.
Respected Honorable Cabinet Minister, Urja and Petrochemical, Sri Patel Sahib, dear colleagues, friends, distinguished from industries, renewable developers, ladies and gentlemen. It is my honor to speak about topic that will India's future, the journey towards green and resilient power grid by 2027. As you know, Gujarat has always led the transforming the power sector from early renewable adoption to strong transmission system. This shows that clear vision and effective execution can deliver reliable and sustainable energy. I'm keeping some slide with me to explain more better. Today's session we have designed for Gujarat power sector overview, operational challenges, planning challenges, interstate transmission utility, future operation and planning challenges, and way forward. This is the current scenario of Gujarat power sector. Here we have total state thermal capacity 6,660.
private generators of around 8,000 megawatt capacity. Central sector share we have 9,000. Wind capacity is going to be 15,000 plus. Solar capacity is 22,000, including solar rooftop of around 7,000 megawatt, which is generally consisting Gujarat as a surplus power state. The challenge is the rising demand. Another challenge is rising demand. Demand rising, but it is already consumption behind the meter by solar rooftop. As it present, we have not overview of exact demand of the state, and that creates the major difficulty for forecasting of power, for arriving conclusion how to manage the system with solar variability. System operations challenges is limited to visibility and distribution energy resources. As I explained, solar rooftop is not directly under visibility of grid operator, and it has led major challenges. Curtailment due to low generation balances. At present, generally demand is running less because of warlike situation between America and Middle East, and it has disturbed our gas supply chain. At present, some industrial units are not working, so we have to impose daily renewable curtailment. That should not be happen. Second thing, transmission constraint and congestion. There are so many cases where solar installation has surpassed our transmission planning, and they creating more pressure to complete the ongoing network facility which is under executed by CTU STU. One other is forecasting and scheduling challenges. Solar is little bit very easy to predict in non-cloudy days, but it is very difficult to predict the wind in a day ahead or a real-time scenario. Second thing, reactive power management. Whatever power has been generated by uh, electronics machinery like inverter, it has no momentum. Momentum is only provided by rotating generators. That also creating the reactive management, power management, voltage management issues in the grid. Second thing is protected fault. Generally, we have devised our protection system with forward energy. Nowadays, we have bidirectional relay, but even in such portion, we are not managing the reverse power flow in the grid. System planning challenges is the major drawback is geographical mismatch because we have Saurashtra and Kutch both are islanding, and that all line emanating from that island passes through central Gujarat only. The Saurashtra and Kutch location has created feasibility for wind power generation, but it is difficult to lay direct line to mainland from Kutch and Saurashtra. We are thinking of underground cable between Kutch, Saurashtra, Saurashtra to Madhya Gujarat and Saurashtra to South Gujarat, but it will take some time. Physical construction, as I explained, every line of evacuation passing through central and Madhya Gujarat. That has also created many ROW issues. Fragmented development. Renewable energy generally installed at the place where land is available. Hence, it remain unpredictable where it will come and when it will come. Climate vulnerability. That is also an issue, but that issue is taken care by demand forecasting mechanism. These are the three drivers for transmission planning up to financial year 2047. Demand growth will be 25 to 42 gigawatt, and in 2047 it will be 63 gigawatt. RE integration for financial year 2035, for which our planning and implementation under progress is 85 gigawatt. For financial year 2047, it will be 187 gigawatt, nearly 200 gigawatt. Demand under green hydrogen productivity or any other form of electricity. Not only hydrogen is solution, other facilities, other form of conversion of energy to be explored. We have 1600 kilometer of wide sea belt here, and I think it is a bottom reservoir for us. We have to create a upward reservoir for pump hydro storage, etc. Because Gujarat has mainly a plain terrain. We do not have facility of hilly area like Maharashtra. That also having very much challenge in for Gujarat for the storage mechanism. Data center load will be envisaged by 5,000 megawatt. Offshore wind project, we have envisaged 1,000 megawatt. Floating solar project is also there. Pump storage is also we have designed. Battery energy storage system also envisaged. And lastly, city development plan of 17 municipal corporation is under planning of STU. Now come to the potential. How much potential Gujarat have? As per estimation with JEDA, CEA and MNRE, the solar potential of Gujarat is 455 gigawatt. Wind potential is around 150 gigawatt. STUs have normally up to that date tapped 19.8 gigawatt, and wind potential we tapped is 9.1 gigawatt. CTU connected RE capacity is 14 gigawatt right now. Wind connection is 6.5. Now the untapped potential is remaining is around 550 gigawatt. At that point, we have planned 55 gigawatt wind and 9 gigawatt of solar. 55 gigawatt solar and 9 gigawatt wind with CTU. And Gujarat has planned. This is the planning of CTU network. Phase 1 and 2 is already implemented. Phase number 3, 4 and 5 is under implementation. You have seen that when you are traveling from Gandhinagar to Surat, you have observed major network development of 765 lines. That is planning of from this uh, phase number 3 and phase number 4. Phase number 5 mostly consisting with HVDC system, which will be implemented by 2030-32. This is the roadmap of Gujarat power sector as a STU. This is the network planning made by STU for evacuation of renewable energy, and it is under implementation. Gujarat Green Energy Corridor schemes of Gujarat supported by MNRE, which is phase number 1 is about to complete, phase 2 is under implementation, and phase 3 is proposed for 16.5 gigawatt energy. Strategic vision is with the green hydrogen outlook, data center growth, and offshore wind development. Offshore wind is envisaged near the Mahua of Saurashtra. Again, generation storage initiatives. Right now, we have 180 megawatt storage system at Sanand and 40 megawatt storage system at Panandru. In between, the response we are receiving is very high for storage also, and in near future we have at least 2 gigawatt storage capacity. These are the mitigation action planned by Gujarat. high capacity storage system and robust transmission system is projected by the Gujarat. Time of use tariff was also envisaged and published by the GUNL recently, in which from 11 to 5, 60 paisa rebate is already announced in the energy uses during that period. Automated grid resilience and unified 2047 roadmap. This is the collective effort of Gujarat STU, CTU, MNRE, MOP, and Honorable Gujarat Government. Renewable energy has strong advantages. High renewable potential at strategic location will give extreme benefit to the state. A transmission planner and system operator, our role is very critical. We must ensure that energy unit of green energy is efficiently evacuated, reliably transmitted, and securely delivered to the end user. The grid connected generators, grid connected consumer, grid connected prosumer are the main element of our power backbone, and we request all kind of discipline from all kind of consumer, rather generator or prosumer or any other grid connected consumer also. Let us work together to build grid that is green in energy, strong in infrastructure, smart in operation, and inclusive in growth. Together, we can turn this vision into reality. Thank you. This is from my side. Now I hand over uh, the session to Mr. Suni sir.
थैंक यू सो मच ए बी राठौड़ सर। थोड़ी देर में हमारे स्टेट मिनिस्टर ऑनरेबल श्री कौशिक भाई वेकरिया सर यहाँ पे उपस्थित हो रहे हैं। सॉरी, my pardon, Kausik Vekaria sir is with us. So I would like to request C.A.B. Rathod sir with bouquet and book, please, with round of applause. We will welcome Honorable Minister Kausik Bhai Vekaria, Minister of State, Energy and Petrochemical Department, Government of Gujarat. Welcome, sir. Now I would like to request our Honorable Minister Sri Kausik Bhai Vekaria sir, Minister of State, Energy and Petrochemical Department of Gujarat. Sir, please give us some. Okay, thank you, sir. Now, without further any delay, let us move toward the most important part of this session, learning from our mentors and panelists. First of all, it's our honor to invite our mentor, Mr. S.K. Suni sir, advisor from CEA, for the insightful session. Please, sir.
Namaskar. Good morning, everyone. First of all, thank you very much, Gujarat, for giving this opportunity. I feel very nostalgic. मैंने ऑलमोस्ट 50 साल हो गए फील्ड में काम करते, और गुजरात के ग्रेट इंजीनियर्स, ग्रेट एडमिनिस्ट्रेटर से जितना मैंने सीखा है, आई ओ माई इंटेलेक्चुअल डेट टू द स्टेट ऑफ गुजरात। तो जब इन लोगों ने कहा कि आप आइए, तो मैं कहा ये हमारा सौभाग्य है कि हम आए। सबसे पहले तो मैं ये कहूँगा कि हॉल फुल है, परफेक्ट जेंडर बैलेंस दिख रहा है और कैबिनेट मिनिस्टर्स ऋषिकेश भाई पटेल and our Kaushik Bhai Patel are present here. Very rarely technocrats get such an opportunity that they sit on this side and ministers listen to that. So to the panelists, it's a challenge for us. I am feeling a bit nervous. But time is essence. We have around 50 minutes. We need to make best out of it. For last one day, while I was traveling, dinner, Rathod sir was with us. The numbers which I was listening, रोंगटे खड़े हो रहे थे. कहा 765, 400 की तो हर आदमी बात करता है. बट मेरे साथ में जो वो कह रहे थे सर 66 केवी रोज एक उपज जाता है. अच्छा इतने जा रहे हैं. I had no idea that गुजरात में इतने सारे 66 केवी स्टेशन हैं और लोड वहां से आता है. So you all should take pride in the grid which you have built. लोड रातों रात 765 से नहीं आता है, लोड नीचे से आता है. और किसने कहा मुझे कि सर ये जो डायमंड इंडस्ट्री उसमें 25 किलोवाट का ओवन एक एक फ्लैट में है, 1 मेगावाट लोड तो रोज बढ़ जाता है. ये स्टोरी हमें बतानी है कि दिस इज व्हाट गुजरात इज, दिस इज व्हाट द वाइब्रेंट गुजरात इज. I would say that topics which have been selected are so chosen. एक है इंटरकनेक्ट करना, जोड़ना. ये हम लोगों ने बहुत सालों में सब जोड़ा. इंटरकनेक्ट करना अब लगता है कि वो सहज काम था, लाइन बन गई, जुड़ गए. लेकिन इंटीग्रेट करना वो है टफ काम. और अब हमारे पास में वो चैलेंज आ रहा है कि हम इसको इंटीग्रेट कैसे करें. इंटीग्रेशन के बहुत सारे पहलू हैं, एक्सपर्ट्स बात करेंगे उसके बारे में, और उसका कोई अंत नहीं होता है. और कैसे इकोनोमाइज करें और कैसे ऑप्टिमाइज करें, ये है हमारे पास में चैलेंज. Honorable Cabinet Minister touched on very sensitive issues, geopolitics. How many of us thought that the whole world will change like this as far as the energy is concerned? So we have to be prepared for future challenges. अभी तक जो हुआ वो तो समझ में आया, लेकिन किसने सोचा था कि इस ढंग से हमारे को सबको इंडक्शन कुकिंग में रातों रात शिफ्ट करना पड़ा. बट दिस इज एन अपॉर्चुनिटी फॉर अस, तो हमें इसको भी लेना है. वाइब्रेंट वर्ड ना बड़ा काफी लोग यूज करते हैं. तो सबसे ज्यादा मैंने देखा वाइब्रेंट मार्केट, बाजार में वाइब्रेंसी चाहिए. लेकिन यहाँ सब्जेक्ट है वाइब्रेंट गुजरात, पूरा स्टेट, वाइब्रेंट इंडिया चाहिए हमें. एंड सो ऑल वॉक्स ऑफ लाइफ हैव टू बी वाइब्रेंट. एंड मैं यहाँ घूम के ये चीज देखा मैंने कि हमारा पावर सेक्टर इज अ कैटलिस्ट. यदि एनर्जी सिस्टम ठीक से नहीं रहा तो बाकी सारी चीजें ग्रोथ नहीं हो पाएगी. तो आई एम वेरी हैप्पी विद दिस. नाउ लेट मी विदाउट एंड देन शांति बिल का जो किया, ये मेरे समझ से इतने बिल्स हम लोगों ने देखे, बट इतना फास्ट होना और इतना फास्ट एनर्जी के बारे में सोचा जा रहा है, दिस इज समथिंग दैट वी आर वेरी फॉर्चुनेट पीपल. It's the happening time, happening place as far as these professionals are concerned. I will not take much time because राठौड़ साहब ने पूरा पिक्चर पेंट कर दिया है. समस्या की लिस्ट बनी हुई है, लेकिन मंत्री जी ने कहा हमें हल खोजना है. समस्या तो है ही, हमें हल निकालना है, और हमारे अलावा और कोई कर भी नहीं सकता, और हम उसमें सक्षम भी हैं, हम करेंगे भी इसको. अभी हमारे पास में पैनलिस्ट में है 5, एक एक योद्धा हैं पूरे. ये अपनी जिंदगी भर इसमें फील्ड में काम किए हैं. दे विल स्पीक फॉर 5 to 7 minutes. वी विल हैव 1 or 2 क्वेश्चन राउंड. लेकिन हम लोगों ने एक इंटरनल पहले डिस्कशन किया, एंड गुजरात जो भी करता है स्टाइल से काम करता है. तो कल एक प्री मीटिंग कराया था इन लोगों ने, हम लोगों का सबका परसों, कि कैसे करेंगे यार. तो वो सब हम लोग कर चुके हैं. तो एक चीज निकल के आई कि हम लोग तो सब अपना अपना बताएंगे ही और एक दूसरे से ही करेंगे, लेकिन ऑडियंस इज एक्सट्रीमली इंपॉर्टेंट फॉर अस. पार्टिसिपेशन वहां से चाहिए हमें. तो पार्टिसिपेशन का कैसे करें, समय तो शॉर्ट है, एक एक बोलेगा तो समय चला जाएगा. मेरा एक रिक्वेस्ट है आप लोगों के पास साथ में, कि जब भी कोई बता रहा है या कुछ समझा रहा है, आपके दिमाग में कुछ भी आए, आप कैसे भी लिख दो, हिंदी, इंग्लिश, गुजराती, किसी में भी अपने पॉइंट लिख दो. बस 2-2, 4-4 कीवर्ड, वो सारे कोई ऑर्गेनाइजर या कोई हम लोगों के पास में भेज देंगे। मैं उन सबको इकट्ठा करके चेष्टा करेंगे हम लोग कि उसके बारे में एक उसका जवाब दिया जाए। वैसे बाद में इंटरेक्शन के लिए भी हम 15 मिनट रख रहे हैं, तो कोई इशू नहीं। और जहाँ तक पैनलिस्ट का सवाल है, पहले देख ही चुके हैं, तो इधर से शुरू करें तो पीसी गर्ग साहब फॉर्मर सीईओ सीटीयू रहे हैं एंड अभी नेशनल सोलर एनर्जी फेडरेशन में हैं, तो ही इज हिमसेल्फ एन अथॉरिटी। पोरवाल साहब ही द डायरेक्टर सिस्टम ऑपरेशन इन ग्रिड इंडिया। इन्होंने ग्रिड को बड़े होते देखा है, जोड़ते देखा है। ऑपरेशन मामले में ही इज द टॉप मोस्ट रैंक एंड ही ब्रिंग्स इन विद ऑल द एक्सपर्टीज। और फिर बालन साहब हैं हमारे मेंबर सीए। तो पूरी जो पॉलिसी चलती है सीए की, पर्सपेक्टिव प्लान कैसे बनना है, फ्यूचर का सोचने का काम सीए का है एंड ही हैपेंस टू बी मेंबर प्लानिंग। और प्रोफेसर जाकिर राथर साहब, ये हैं बुद्धि चीज बताते हैं। ये हम लोग को बताते हैं कि कैसे कैसे दुनिया में क्या क्या हो रहा है और आप क्या कर सकते हो। इनका बहुत काम है और हम लोग इनसे बहुत कुछ सीखते हैं, तो ही इज ऑल्सो देयर। और लास्ट में के गुप्ता साहब जो कि प्रेजेंट सीईओ सीटीयू हैं। तो आई मस्ट थैंक गुजरात ऑर्गेनाइजर्स, इतना बढ़िया पैनल स्टिच करके जो लाए हैं, इसी के लिए एक ताली होनी चाहिए। प्लानर्स, ऑपरेटर्स, पॉलिसी मेकर्स एंड एकेडेमिया, ऐसा कॉम्बिनेशन बहुत कम मिलता है। और फिर मंत्री जी लोगों के सामने। तो दिस इज व्हाट इट इज। विदाउट टेकिंग एनी टाइम, आई वुड नाउ रिक्वेस्ट one by one all the panelists to very succinctly express, because issues has already been listed by Rathod sir. We have to give solutions and we will be open to the question answers and interaction. Thank you very much.
मैं इंटरवीन करूंगा। सुन्नी साहब ने सबके बारे में बताया, बट मैं बस एक ही शब्द बोलूंगा, ये हमारे पितामह हैं। हम सब लोग इन्हीं से सीखे हैं और बड़ा डर लग रहा है इनके सामने बैठने में। सो लेट अस होप क्या होता है। थैंक यू सर, थैंक यू। थैंक यू सर, थैंक यू वेरी मच। थैंक यू मिस्टर्स and entire Gujarat team. First of all, really I'm enjoying participating in different activities in Gujarat. I was in Gujarat for quite many years. I was in power grid and I have worked a lot in this area, particularly Kutch Khabda area. Now here I want to highlight that India's, the topic says green energy rich grid by 2047. This is not just by adding the capacity, as Sunny sir also said. It's about reforming the entire energy ecosystem of the country, right from generation to consumption. Earlier we were working with the, just centralized and very firm site of, predictable grid. But now we are we are moving towards a decentralized variable grid, where almost 70 to 80% of energy is going to come from the renewables. So one can imagine the difficulties. Today, Purval Sahib is facing a lot of difficulties with the integration of renewables in the grid. A lot of grid resiliency requirements have come up. So it's a big challenge, definitely. From my experience in power grid during execution and then as a planning in CTU, I want to just highlight some strategic realities. First is the time mismatch. We all know that renewable comes in say 18 to 24 months time, whereas the transmission takes 3 to 5 years with a lot of challenges. So there is an inherent mismatch between the two, and that causes curtailments, inefficiencies. When I talk about the transmission, it's not ISTS. I talk right from ISTS up to the distribution level, intrastate network also. That's very, very important. And then we have underutilization of asset, like in renewable, particularly we are making transmission for solar. So in the daytime, lines are overloaded, and in the non-solar hours, they are not utilized at all. Of course, the non-solar hour connectivity introduced by Commission will mitigate this problem to some extent. And then the flexibility. We all know the duck curve. I think many of you may be knowing about the duck curve, that in the morning there is a huge demand from the grid. In the daytime, the demand from the grid goes down with solar solar generation. And in the evening, again, the demand goes up. When I talk about the demand, it is a conventional generation demand. And that is creating a lot of stress on the thermal generators. We have to ramp down the generation in the daytime. We have come down to the technical minimum. Demand is to go even further below, which is very, very difficult. And in the evening hours, we have to ramp up the generation. And that's again a problem. So our intention is to flatten this curve. The duck curve should be flattened. It should not be like duck. And for that, definitely storage is coming up. Storage will mitigate this problem to some extent, and the market evolution is also required. We need to go for the time of the day tariff so that some of the load which is very much not critical to the time, that can be shifted from the peak, evening peak, to the solar peak, so that the curve can be flattened. And then the another important thing is the DISCOM. DISCOM's health is not good. We have to work on DISCOM's health. A lot of is to be done now with introduction of rooftop. That's very great idea of having rooftop, but this bidirectional flow, the DISCOMs, they never know how much power is going to come into their grid from the prosumers, how much demand is going to increase during non-solar hours. So we have to make the distribution companies as distribution service operators so that they are fully equipped with forecasting tools. They should know when the power may flow from the prosumers to the grid and when grid will be in more demand. And for that, the pricing model and all that they can introduce so that this kind of problem can be mitigated. And for Gujarat, I will say just that Gujarat is in itself is a complete country. You have resources, solar, wind, you have manufacturing, complete ecosystem is available for wind manufacturing, I mean turbines, for solar module manufacturing, right from ingots up to the modules. And then you have got the most important thing, that is the load. Today, when we talk to the CTU, they always tell me, where should I take the line? The starting point is known to me, but the end point is not known to me. Where should I take this HVDC line? But Gujarat is the place where you have tremendous load. So you have resources, you have load. Please make your own intrastate network. Today's topic, I was very happy by seeing the Rathore Saab's presentation that he has not talked about a lot about the ISTS. He was focusing on intrastate. Please develop intrastate. This is my request. Gujarat can become a gateway to the world for renewable integration, and it will be a great, great model for other states to follow. So please focus on intrastate network. That's very, very important. Thank you. Thank you very much.
Honorable Minister and Honorable Minister of State for Government of Gujarat and all distinguished panelists and distinguished participants here. A very warm good morning to all of you. As everybody has said till now, and also Rathore Saab has mentioned that what are the challenges. So I will not say that they are challenges, they are opportunities for us to grow. And present is the, as Soni Saab has mentioned, that present is the time is you know, for the country, for what, but for all. And we can pave the path. importing a lot of, say, technology from outside, but now is the time when we can export technology. We can export the knowledge to other countries. So that is what the opportunity amongst us is, and we must utilize this opportunity to the fullest. As far as renewable integration is concerned, there are main two challenges which has been already highlighted. One is the variability and the unpredictability of the generation of RE, and another is that other technical challenges with the integration of RE, that how we know how we make this electricity system, entire ecosystem, stable, secure, resilience to the different type of challenges, different type of issues which come to the which grid faces. So these are the two main challenges. There are many sub stories behind this main story. So first of all thing is that we are already, as a country, we have a very good ecosystem for the meteorological department. Then the ISRO is also there. So we have got to utilize those resources for better forecasting of our resources, and that is what the first main opportunity is for us, is that we must have a very better forecast. As far as rooftop solar is concerned, I understand that MNR is already working on a project that all this should be wired and this should be visible. But apart from that, even if it is not visible, we must have, each distribution company must have that how much is rooftop solar is getting installed. This static information still can give lot of information, that today this must say in the Surat city, say uh, 20 gigawatts rooftop solar is there. This 20 gigawatt will not be there in during the, say, even if you take 70% of this, say that much megawatt will not be required during daytime, and during evening time this will be required. So this type of prediction, this type of technology uses into the our load forecasting or generation forecasting can give lot of information to us, and we can definitely make the grid better balancing. Second point, regarding the, say, from technological point of view, there are again, Professor Saab will mention that because of this IVR, there are certain issues, that how these IVR, because earlier we were knowing the machines which were rotating mass. So there was slow dynamics was there, and everybody was moving in the same way. All the dynamics were similar type, may not be exactly same, but they were in similar type. So knowing them was pretty say straightforward. I should not say straightforward, but this was also, there were also challenges at that point of time. But they were quite. We have overcome those things, and because of those, we were able to manage things much better. We know, predict that this is how the system will behave during different conditions. But as more and more IVR comes in the system, their dynamics is totally different. Each manufacturer can come up with different type of dynamics, different type of controls in there. So they are quite fast controls, and fast, and also we don't know much about that. So therefore, the technical know-how of our system, entire ecosystem, is becoming extremely important. Whether it is STU, whether it is CTU, whether it is DISCOM, or whether it is say RLDC, SLDC, anybody, or even the generators, those who are bringing a lot of technology into, or lot of their say generating stations into the grid, they also requires increase of the technical know-how of their dynamics uh, truly well. Then only we will be able to predict better how the system will behave and able to control that. As I have already said that because these are fast controllers, they can be controlled. We can make them work better. That is the mood theme, that we can make these controllers work good for the system. Though presently we feel that they are slightly not good for the grid, but we should think another way, that they can be made better to dance to our tunes. That should be the area. For that only, what we need to do, that everybody has to be open. As most of the developers sometimes, or OEM sometimes, prefer not to give those models to the different utilities, or they don't want to again remain say in any garb that this is intellectual property rights or anything. they remain more focused toward that. They don't want to tell that. But somehow this will come out. In a present issue, present say time of so much openness, this areas also has to open up, and we need to bring more and more technology in this area, more and more minds in this area. Therefore, this can be solved to that extent. And whatsoever say our transmission network is improving, transmission network will continue to increase. But apart from the transmission network, also we need, as Dr. Sahib has mentioned, that something different, something more, which will give us inertia, which will give us reactive power controllability. You all must have read about the blackout in Spain, why this was not, why this happened. So everything is in public domain. You might have read all those things, but we need to be prepared for that. And I'm quite happy to say that from the day one we said that no dynamic reactive power control has to be there. And fortunately, all our policymakers, everybody agreed for that. And at least at the interstate level, I'm pretty sure that things are moving fast. I want that at a state level, a STU level also need to be more and more rigor has to be there in that area from the STU and SLDC, so that any plant, anybody comes to the grid, he follows the system. Apart from this, this new type of load will also be coming, say data center or the green hydrogen load which are coming. They are also inverter based. They are also IVR. So similar thing has to be from the day one, from today itself. These things need to be mandated for this. CA is already working on that. That how the regulations should come up. So from the start, these regulations are in place and everybody follows the for everybody's say have a time for the grid resilience. They put forward their information, they put forward their equipment accordingly, so that there is no issue for the grid, or these can be solved in a better coordinated manner. So these are the few things. Apart from that, say from the storage side, or say long duration storage, everything else is important, and this will definitely help. But we need to be very cooperative, very collaborative, and learn from each other. There is no time that okay, I know only that, nobody else know and nobody else should know. This is not the time. We must collaborate from the, whether it is generator, they must be quite open and collaborate, so that our grid remains resilient, responsive, and say very secure system, because we can't afford to any failure in the grid. That is the I think last March we have a disturbance in the south of Gujarat. Fortunately, now 765 kV line has come, so this is quite good. But I understand that again Navsari 220 kV lines is coming now, so therefore that will also get integrated. So that is also we need to focus on transmission infrastructure also. And another one more important point is that we must in say technology used in optimization, whether it is optimization for power, whether it is optimization for transmission, whether it is optimization for our controls, everything, everywhere we need now technology. And for that we all has to work a lot in conjunction, and more towards the basics of the power system, more towards those things. If comes, definitely we can always overcome whatever challenges comes in our system. Thank you. Go there, sir. Yeah, I'm waiting for the questions from the audience, because the most important is interaction. And what is in your mind? And don't, assassinate any idea. All ideas are good. We want to understand that what are the issues which are in the mind of the people, so that the panelists can respond to that. That's our approach. 5 to 7 minutes, sir. 7 minutes. There are lots of questions from Mr. Bala. Respected
Respected Cabinet Minister Sir and State Minister Sir, Namaskar. Namaskar to all the audience and the participants, my fellow panelists and moderators. I gone through your slide just now. So here I am from planning department. Uh, Mostly planner, you want to be optimistic or pessimistic, correct? First you will decide that. You want to be optimistic or pessimistic. There ends story. Suppose you are pessimistic, then you have multiple scenarios, correct? Plan A, plan B. So for this you need data. Data is what? See, for example, 20, 30, 30 34, 35, hourly demand, what is hourly demand? That is my problem. How to predict hourly demand 20, 30, 34, 35. So we want to have the past 10 years data, your load profile. We have tools and predict the, based on your peak demand energy requirement, we predict the future demand hourly, 876 hours, what will be the demand? Then what are the resources we are having? Existing, under construction and planned ones. Then we want to dispatch hourly energy at that futuristic year. So here the important thing is how to predict. Whereas if you build the oversized capacity, the planning reserve margin is more, you would incur more cost, power cost will go up. So you would optimize the cost. We have tools. We optimize the cost of generation over the next 10 years, you can say. So that's what we are doing. Load cycle follows the, you can say, people's life cycle. So whatever we do, when we are awake, we consume more power. When we are not awake, we consume less power. So this is the fundamental. And also now we want to tap all the renewable energy sources. So challenge is coming now. What I am saying now we are going to use AI more and more, build up the database. Database is very, very important. Because many states we are getting data not coming and we have to assume some data. So I request all the engineers to build up the data. First you have to measure the data also properly with RTU, whatever you are having now, build up the record and have the data. Then only in futuristic AI tools can use the whatever methodology is there, pattern recognition, past data, you can get the quick result also. So I have some few points I want to share with you, problem we are facing. So whenever you plan the demand, estimate demand, please ensure that all the government schemes are taken into account. Government schemes are there, central schemes are there, state schemes are there. So all you have to consider. For example, PM Kusim scheme is there, Surya rooftop solar. Rooftop solar we were talking about. And last week we had meeting also. That is, ministry wants to meter all the rooftop generation. So we want to amend the metering regulations. So already we recommended ministry also, we will be doing the job. So each behind the meter, each solar generation will be transmitted to control center, SLDC. Then you can know how much is at any given time, how much is the generation, rooftop generation. That job we are doing. And also, see, any geopolitics, the load will come on the grid only, cooking. And even coal also, I remember 5 years back, the coal also will come on grid. We have lot of requirements, electrical vehicle, green hydrogen, data center, they want reliable supply. Reliable means what? Unless I go to EHV, I won't get reliable supply. So 400 kV, 220 kV supply, then transfer, then step down to lower voltage, then consume it, cost will go up also, so to pay. So that reliable data center is very, very important. And we have a lot of government targets are there, 2030, 2047, 2070 also, even Gujarat also having a lot of schemes. Now you are having 32% energy from RE, and 2030 you want to go above 50% RE, Gujarat. And 2047 you plan to have 90% RE generation. You want to meet fully from RE only. So can you imagine the scenario? Suppose 1 or 2 days no sunlight. How to go about that? That you have to plan for that. Storage, how much storage you give also. Sometimes solar eclipse, I think Purvasap is there. Solar eclipse, how to how to manage. We have a lot of meetings also to control. So these are my things. Other things are there. Other thing, Gujarat. And Gujarat, we have a lot of studies also we completed. RES studies for 34, 35. The public domain available. Transmission network also are there. And one more thing, the important thing I want to raise the point is here, skill development. Skill development is very, very essential. Skill development. See, you are getting new tools, inverter-based resources, how to handle. Many are very happy up to the come COD. COD date declare हो गया and operation हो गया, all are happy. Who will operate? Who will maintain it? How to dispose them? How to, for some wind turbines, how to repower, repurpose. These are the requirements. And also you want to switch over, you say 90% from you want RE. So what will the people who are working in that conventional power plant, coal plant will do? Where they will go? How to de-deploy them, retain them? This is a challenge. Challenge where social impact will be there. So this also would plan. This is very, very important. This is, we call just transition. Just transition means training the people who are in the conventional industry. Tomorrow they will switch out to this one. And I gone through your this all. I think all are accessible. All we can do it also. And all data is data are there. I will try to answer your challenges you are having. Yes, sir. I will take 1 minute, sir. 1 minute I will take, sir. So real-time monitoring of rooftop solar generation, I told that metering is being, meter regulation is being amended. Inaugurate demand forecasting due to hidden generation. Yes, true. The all factors and CE is working on the working along with IMD, and we are preparing the guidelines for the precise weather forecast. That is almost nearing completion. Based on that, you can predict the RE very precisely. That is being done. Difficulty in grid balancing and scheduling. Very, very important. Grid balancing is very important. So flexibility. Generation, many units are not able to flexibilize. And I would suggest that you have the one base load units and remaining you can vary it also. Otherwise, difficult to how to operate now. Base load units to be declared, then remaining units you can keep it as a variability. 50% or 40% it is there. It is there in the regulation, but many are unable to give. So this is a big challenge, how to absorb and who will incur the cost. That problem is there. Curtailment, it is there. Demand during low profile curtailment. What to do now? Unless you have storage, you can absorb. So curtailment is only major problem is storage and flexibility of the existing generation. That you would compute. See, just talking is one thing now. You all should be quantified. Whatever points you have shown to here, it should be quantified. Then only we can try for solutions. Must and status, it is already there. Corridor overloading during peak origin injection. This all are, I think, they are already assessed now. Forecasting, I told you already. I think Gujarat, we are doing that. ISGF is doing some Surat only, I think, Surat, that rooftop solar being monitored real time, database being built up, and we want to replicate this also in the other parts of the country also. So, Torrent they are doing. So this also we are doing. This also I am aware of that. And reactive power voltage management, this is a big challenge. And you have to plan, you have to quantify how much is there, how much is the requirement, how much is there. Quantify and address the issue, and this over voltage issue is there for many years. Even conventional grid also. Now RE is now increasing there. This is the issue. Protection fault level challenges. This is also another area. Please train all your manpower with the technical knowledge. That is very, very important. I told news sources also. Modeling is very, very important. Modeling is very, very important. And many of us are not knowing how to model the solar, how to model the wind, how to model the inverters. And Grid India asks for a lot of data. Many are unable to give data also. So connectivity time they are asking now. Please train your manpower. Technical IIT professors are there. You can train them, and then you can tackle the issues. Otherwise, difficult to manage the grid. Very, very difficult to manage the grid now. So now time is running up. Okay, sir. I will with this one I will close my speech. Any queries? I will try to answer. Thank you. All the best for the Gujarat. Thank you, sir. Thank you.
Um, a very good morning, Honorable both the ministers. I am and other participants. More importantly, I am very pleased to be here today on this very important topic of greening the grid, future grid. From IIT Bombay, we have been associated with Gujarat power sector. We have been doing studies for last 8+ years on the Gujarat power system, looking at different aspects, primarily through SLDC and through GETRI and other, power sector stakeholders here in Gujarat. So, as I understood with my limited understanding of Gujarati language, Honorable Minister was mentioning that we should aim at number one, not for the sake of number, but through a healthy competition. But what I believe is Gujarat is not having any choice except aiming at number one in the power sector because they are uniquely placed. This is the only state besides Tamil Nadu which is blessed with both wind and solar. And then the load centers. So therefore, it is in different ways unique compared to other states. And the challenges are also unique, that those are not equally there in other states. So let me try to make it understand in a simple non-technical way the transformations that are happening in power sector. Earlier we used to have a load, there used to be generation, predominantly thermal, then thermal generators generate kiya or load centers were there, load center was receiving the load or consumption ho rahi thi. Now what is happening because of this climate change? There is this net zero target emissions, but the emissions are not only in power sector. Emissions power sector में भी है, transportation sector में भी है, industrial sector में भी है, cooking, heating, cooling, water, everywhere. So in order to achieve this net zero target, this power sector is uniquely placed. क्योंकि electricity vector ऐसा है that no other energy vector actually has those advantages. One of the, I'll just mention two, there are many. You can switch on the power station here and instantly you can start drawing the load from the farthest end of the state, rather farthest end of the country, instantly. Can we do that in any form of other energy, mechanical energy, chemical energy? नहीं कर सकते हैं. It is at speed of light that we can transmit electric energy from one point to another point. Second most important is relatively. Renewable energy integration is a target, is a huge, is a topic, is a huge challenge. But relatively, it is easy to integrate more renewables in the power sector compared to other sectors. इसीलिए, if you see the transportation sector is getting electrified. Transportation sector, the energy that was being used was through the petrol, diesel, right? Gas. It was not coming through the grid. Now the entire electricity is supposed to come from the grid for the transportation sector. Green hydrogen. Hydrogen has been, in consumption in generation for ages for the industry. Now green hydrogen, so it will come from the electricity. Heating, cooling is getting shifted to electricity. So a lot of these transformations in energy vectors are happening and they are getting shifted to the power sector. But power sector तो डिजाइन हुआ है नॉर्मल लोड के लिए. इलेक्ट्रिक व्हीकल आ गया. इलेक्ट्रिक व्हीकल एक चार्जर टुडे इज ऑफ 6 किलोवाट कैपेसिटी जो घर में लगाते हैं फॉर ए कार. आपका टिपिकल लोड जो कनेक्टेड है 3 किलोवाट है एक हाउस में. एक ईवी ऐड कर दीजिए 9 किलोवाट हो रहा है. बट डिस्कॉम हैज डिजाइन ओनली फॉर 3 किलोवाट योर हाउस लोड. कहाँ से आएगा? 3 times. Rooftop PV. Rooftop PV has been mentioned multiple times. टेक्निकली अभी क्या है कि दिन में यू आर नॉट एट होम, कंजम्पशन इज लेस, यू आर जनरेटिंग दिस रूफटॉप जनरेशन. अब देर इज अ यूनिक इशू विद दिस जनरेशन एट ऑफ सोलर. जैसे आप यू आर इंजेक्टिंग मोर पावर इन द ग्रिड, वोल्टेज increases. So you have over voltage issue in Gujarat. Many feeders are already experiencing that. तो दिन में तो ओवर वोल्टेज इशू है, इवनिंग में आप घर आते हैं, यू स्टार्ट कंज्यूमिंग द लोड, देन यू स्टार्ट कनेक्टिंग योर इलेक्ट्रिक व्हीकल इन द इवनिंग, तो पीक लोड आ गया. सो डे में तो यू हैव ओवर वोल्टेज इशू, इवनिंग में यू हैव वेरी लो वोल्टेज इशू इन एडिशन टू कंजेशन. सो द सिस्टम इज बिकमिंग वेरी यूनिक. सो द चैलेंजेस आर बिकमिंग कंप्लीटली डिफरेंट. जो जितना ये ट्रांसफॉर्म हमारा लोड ग्रोथ 5% दिखाया ऑलरेडी गुजरात के लिए, यूरोपियन कंट्रीज, अदर वेस्टर्न कंट्रीज का लोड ग्रोथ तो जीरो है ऑलमोस्ट. इन कुछ सम कंट्रीज इट इज नेगेटिव, बट वी हैव a huge demand growth year by year, and that is naturally happening because of industry. And then on top of that, the transformations of other energy vectors जो grid पे आ रहे हैं, that is adding to that. So the planning is becoming very, very critical, adequate planning. And now it's not only planning of the grid, it is not only planning of the infrastructure, it is equally planning of the operation of the grid. ग्रिड में कन्वेंशनल जो जनरेटर रहते थे, दे आर यूनिक एंड ब्यूटिफुल एलिमेंट्स ऑफ द ग्रिड. उनमें एक ग्रिड सपोर्ट, इनहेरेंट ग्रिड सपोर्ट कैपेबिलिटीज है. ग्रिड में कोई भी डिस्टर्बेंस आ गया, दिस जनरेटर, कन्वेंशनल जनरेटर यूज टू सपोर्ट द ग्रिड इनहेरेंटली इन मनी वेज. कोई स्पेसिफिक इंटरवेंशन नहीं चाहिए, इनहेरेंटली दे आर सपोर्टिंग द ग्रिड. अब वो आप धीरे धीरे निकाल रहे हैं for the very good reason. And then we are adding these renewables. Renewables by nature technically, not environmental, by nature they are not grid supporting. They don't care कि grid में क्या हो रहा है. They all care about मुझे कितना generate करना है. I will just pump that into the grid. I don't care inherently. Of course with controllers it will. I don't care what is happening on the grid side. Reactive power वो डिमिनिश हो रहा है. इनर्शिया, हम गुजरात ग्रिड का स्टडी कर रहे हैं, इनर्शिया स्टडी कर रहे हैं पूरा 2030 2047 में. हाउ डू यू ensure that there is an adequate inertia in the system. Conventional generators are getting displaced. How do you ensure that there is a adequate inertia in the system? That planning is very, very important. Storage कहा जाता है, storage is going to solve all the problems. Why should we focus only on storage? Certainly we should, but is the storage the solution for everything? Not necessarily. We should actually explore other options also. जो मैं EV का बता रहा था, 3 times लोड हो रहा है इवनिंग में चार्जिंग में. सेम EV we have been doing one pilot at IIT Bombay. एक इलेक्ट्रिक व्हीकल है which is getting charged from PV during the daytime from office. Evening में it is getting connected to the typical car, EV car. It is getting connected to the house. It is supplying the power for the entire night in the house from that electric vehicle. Not only to the house, in the evening hours it is able to inject power back to the grid. जो आपका peak demand issue है, it is doing completely reverse. This 6 kilowatt, we have over the 1 year period, we have been able to inject power of 3 to 4 kilowatt in the evening hours to the grid. So the same asset, which was electric vehicle, which was becoming a challenge for the grid, can actually address the most critical issues of the grid. So therefore, there have to be some innovative ways also to be explored. Before concluding my last point, we being in the research and academic community, we have a privilege of doing studies of something which may look crazy in the current state, but we anyway do those. And later on, after 15, 20, 30 years, the same practitioners experience that. So renewable issues are abhi. We have been research studying for 20 years back. जो events हो रहे हैं अभी. So therefore, now renewable is becoming everywhere, major issue because we are experiencing it. But when we talk of the planning, is for the future. There are several transformations and the new technologies that are coming, inevitable. वो आ जाएंगे grid में. So we should also equally focus on those before waiting them to come and start experiencing challenges. So we should equally focus on those new emerging technologies that are coming into the grid because of this transformation that I was mentioning. Every sector is getting shifted to the electricity vector. So we should do those studies. We should understand those challenges, nuisances in the context of the Indian grid, and we should take those inputs in the context of this planning. Last, 1 second. Last, no, last. Sorry. Yeah, just one point. I'll conclude with that, which I think Mr. Balan and you also mentioned, touched upon, is the capacity building, which is very, very critical. If our manpower, if our skilled manpower, which is working in the field, is not well equipped, there are many things that are bound to actually pass through our process and haunt us going forward. So therefore, enhancing the capacity building is very, very critical. One simple example is renewables are getting added. If you are getting a model from a RE developer, if your staff is not well equipped with understanding मुझे क्या मिला है मॉडल में, ये सही है नहीं है, कहाँ कहाँ प्रॉब्लम है, they will not be able to check those issues at the start of the connection. Then later on they will be able to determine that these were the issues that have been slipped out earlier and now we are experiencing. I'm just giving an example. There are many other examples, even the operational aspects. So if our manpower is well skilled and it has to be updated because the grid is changing like anything, new technology, so many transformations. So if our manpower which is working in the field in the operational control centers is not actually well equipped, it is bound to have a lot of difficulties in the future with these new technologies that are coming into the grid. So with this I would conclude. Thanks so much.
Thank you very much, sir. Thank you. And I'm fully agreeing with what Professor Jakir was telling regarding Gujarat, its uniqueness, regarding its geographical uh, location. Then specifically, he was comparing Gujarat with Tamil Nadu in terms of the availability of solar and wind in adequate quantum, both in Tamil Nadu and Gujarat, as well as the coastal areas, the load growth. So it's a kind of unique state. But I just want to add one or two more things. What makes Gujarat more unique is that गुजरात में लैंड भी काफ़ी अवेलेबल है जहाँ पे कि हम सोलर प्लांट्स लगा सकते हैं. सो दैट मेक्स गुजरात मोर यूनिक एंड इवन मोर देन the mindset of the people of Gujarat, which is more and more industry oriented, that makes even more unique to Gujarat. जिसमें कि आज की जो हमारा सिनेरियो है जहाँ पे कि जनरेशन बढ़ता जा रहा है और उस जनरेशन को कहीं ना कहीं यूज करना है लोड्स पे और उसके लिए ज़रूरत है इंडस्ट्री की. और इंडस्ट्री केवल इंडस्ट्री बोलने से नहीं आता है, इंडस्ट्री पब्लिक जो वहाँ की पब्लिक होती है उसके माइंड सेट से आता है. और आई थिंक गुजरात हैज़ दैट काइंड ऑफ माइंड सेट इन देयर पब्लिक जो कि इंडस्ट्री ओरिएंटेड है. सो दैट वाज वेरी वेल पॉइंट रेज्ड बाय प्रोफेसर जाकिर. One more, he has given one more beautiful example or the future perspective, जहाँ पे उन्होंने बताया कि कैसे एक कार की बैटरी को आप दिन में चार्ज करके कार चलाइए और रात में उसी पावर से आप अपने घर का घर में यूज करिए. सो ये जो है डिफरेंट काइंड ऑफ सिनेरियो जो आ रहे हैं, जो हमारा पावर सिस्टम का जो सिनेरियो चेंज हो रहा है, किस तरह से ये चेंज हो रहा है और आगे आने वाले समय में ये किस तरह से आगे चेंज होगा, दैट पिक्चर वाज गिवन बाय प्रोफेसर जाकिर. सो दैट इज very well taken and I think we have to see
in all such kind of things कि आगे आने वाले समय में जिस तरह से एनर्जी मिक्स चेंज हो रहा है, ये सब चीज़ें कैसे आगे बढ़ने वाली हैं। अगर प्लानिंग की बात करें, ट्रांसमिशन खासकर ट्रांसमिशन सिस्टम प्लानिंग की बात करें, तो आज से 20 साल पहले जो सिनेरियो था, उसमें हमारे पास जो जनरेशन सेंटर्स थे, जनरेशन सोर्सेज थे, मोस्टली कन्वेंशनल सोर्सेज थे, जो कि ईस्टर्न पार्ट ऑफ इंडिया में चाहे वो एमपी, छत्तीसगढ़, उड़ीसा, झारखंड, उस एरिया में अधिकतर हमारे पास थर्मल जनरेशन थे। नॉर्दर्न बेल्ट में हमारे पास हाइड्रो सोर्सेज थे और वहाँ से ट्रांसमिशन लाइंस ट्रांसमिशन की प्लानिंग होती थी। एंड लोड सेंटर्स वे आर मेनली लोकेटेड आइदर ऑन वेस्टर्न कोस्टल एरियाज, गुजरात, महाराष्ट्र एंड ऑल दैट, और नॉर्थ सेंट्रल पार्ट, दिल्ली और इसके आसपास का एरिया, और कुछ साउदर्न पार्ट में। तो उस तरह से ट्रांसमिशन की प्लानिंग होती थी। आज की डेट में सिनेरियो जैसे आरी का इंटरवेंशन हो रहा है, आरी का इंटीग्रेशन हो रहा है, पूरी जो टोपोलॉजी है वो चेंज हो रही है, जहाँ पे कि अब आरी रिच स्टेट्स जो हैं उसमें राजस्थान, गुजरात और कुछ स्टेट्स सदर्न साइड्स के हैं। तो नाउ लेकिन अगर आप देखें तो लोड सेंटर्स आज भी वही हैं, लोड सेंटर में ज़्यादा चेंज नहीं हुआ है, लोड सेंटर आज भी वही हैं, लेकिन जो हमारे जनरेशन सेंटर्स हैं, आरी रिच सेंटर्स हैं, वो डिफरेंट हो गए हैं। तो नाउ जो ट्रांसमिशन प्लानिंग का जो क्राइटेरिया है वो पूरा चेंज हो रहा है। उस समय का अगर आप देखें, जो बड़ी बड़ी एचवीडीसी की लाइंस बनी हुई थी, यूनिडायरेक्शनल लाइन थी, उसमें उस समय प्लान हुआ था कि नॉर्थ ईस्टर्न रीजन से पावर आएगा और नीचे की तरफ साउथ की तरफ सप्लाई होगा, सेंट्रल एरिया में सप्लाई होगा। आज ज़रूरत है कि बीच बीच में पावर हमें ऊपर की तरफ भी देना पड़ रहा है, नॉर्थ साइड में के अलावा ईस्टर्न साइड में, नॉर्थ ईस्टर्न साइड में पावर भेजना पड़ रहा है। सो दिस इज द चेंज्ड सिनेरियो। नाउ coming to the numbers, presently we are talking about 500 gigawatt of non-fossil fuel integration, and largely we have either implemented or planned, or it is under implementation. So we are fully confident that by 2030, whatever was planned, 500 gigawatt transmission system for non-fossil was planned, and I think it will be fully ready by 2030 and even well before that. Going ahead, now we have planned for 900 gigawatt of non-fossil fuel integration by 2035-36, and we are working for that. So by 2035-36 time frame, we will be ready with 900 gigawatt of non-fossil fuel transmission system integration. And if we talk about 2047, so we are foreseeing that around 2000 gigawatt of non-fossil integration will be required by that time. So we have to gear ourselves, but of course there will be lot of challenges, lot many things we have to see, that how the transmission topology has to be optimized, not only in the terms of building new transmission lines, but we have to see that how we can utilize in a better way our existing transmission lines, how we can operate our existing ROWs and existing transmission lines, and more importantly, how we can use the storage systems, because predominantly whenever this RE integration will be more and more in the system, presently it is in the range of 50%. Now it is, we are seeing that in the uh, in the time frame of 2047, जो हमारा आरई का इंटीग्रेशन होगा वो 70 से 80% के आसपास होगा, उसके अपने अलग चैलेंजेस रहेंगे। तो उस आरई पावर को प्रॉपरली यूटिलाइज करने के लिए we need proper storage, whether in the form of battery or in the form of pumped storage or any other form. मोर इम्पॉर्टेंटली अभी हम ज़्यादा बात करते हैं जनरेशन की। जनरेशन के साथ में जब तक लोड साथ में नहीं आएगा तब तक वो जनरेशन आइदर सरप्लस रहेगा, कर्टेल रहेगा। वी हैव टू टॉक अबाउट द लोड्स, सो वी हैव टू सी द विजिबिलिटी। हमें एक चीज़ सोचनी होगी कि ट्रांसमिशन की प्लानिंग तब तक नहीं हो सकती है जब तक कि जनरेशन के साथ में हमें लोड सेंटर्स का पता ना हो। सो वी आर लुकिंग फॉर मोर एंड मोर लोड सेंटर्स in the form of either green hydrogen, green ammonia, or data centers, Now, one more form of load center is coming in the form of e-mobility, vehicles, and now we can see the with the current geopolitical scenario that cooking may be one of the major area where this electricity will be required. So that will be one major area. We have to we have to forecast for that. We have to see that in the coming time how this load grows and how we have to meet that, and how we have to plan our system so that we have to meet such kind of bulk loads, either green hydrogen, green ammonia, data center, EV, or cooking load with the available generations. So I think I'll not take much time. There are lot many questions to be answered. Suni Saab is waiting for the questions to be answered. Thank you very much.
Thank you so much, Honorable Minister, sir, for હેલો સાહેબના વ્યસ્ત શિડ્યુલના કારણે સાહેબ થોડા અર્લી લીવ થઈ રહ્યા છે. તો થેન્ક યુ સો મચ સર, ઓનરેબલ મિનિસ્ટર સર. Onwards, our session will be continued. Thank you so much, sir. Once again, thank you so much for your valuable presence. We will continue with our seminar. Onwards, Sri PC Garg, Principal Advisor, and SEFI. Hand over to you, sir.
How much time do we have? Are we overshooting the time, or do we have some time? We have time. So, first of all, it's a vibrant audience. I have seen so many questions, and let's try to answer. But before that, probably you wanted something to be raised. You can, yeah, Mike.
थैंक यू. माई सेल्फ अश्विन पंड्या. मैं पहले पावर ग्रिड में ही था और लकीली और फॉर्च्यून है, हम लोग के दो पावर ग्रिड के दिग्गज यहाँ बैठे हैं. मेरा सवाल बेसिकली बालन साहब से है, जो प्लानिंग के मतलब मास्टर है. मैं आई विटनेस हूँ पावर ग्रिड में. मैं जब था तो गुजरात में पावर ग्रिड था ही नहीं पहले. जब शुरू हुआ 92 की बात कर रहा हूँ, पावर ग्रिड का कहीं नाम नहीं था. ठीक है सर. और जब पहला सिस्टम बना सीटीयू के थ्रू पावर ग्रिड का, तो इतना जायंट सिस्टम देख के हमको लगा कि ये लोड कभी यूज़ ही नहीं होगा. 15 मेगावाट पावर फ्लो होता था कंटिन्यू 2 साल तक. गंधार सिस्टम जो की बात कर रहा हूँ. तो हम लोग, मेरा सवाल ये है सर कि अगर हम उस टाइम जो डाटाबेस लेके कि कितना लोड कंज्यूम हो रहा है, उसी आधार पर हम अगर सिस्टम बनाएंगे, तो वो तो आज हम लोग इतनी सारी पावर ग्रिड के इधर गुजरात में लाइनें हैं, इतना लोड है, सब कुछ है. लेकिन अगर हम उस टाइम डाटाबेस पे बनाते तो कभी हम यहाँ तक पहुँचते नहीं. जैसे गर्ग साहब भी कभी काफ़ी बार बोलते हैं कि जितने हाईवे बन रहे हैं, और हम तो इतने लकी है कि हमारे पास नरेंद्र मोदी साहब जैसे विजनरी है कि नहीं, उनको छोटा कुछ पसंद ही नहीं आता है. तो आप लोग ऐसी जगह पे सर बैठे हैं कि जहाँ आप कोई भी प्लान रखोगे तो वो प्लान अप्रूव होने में मुझे जरा भी संदेह नहीं है कि ओके हो जाएगा। यहाँ भी यंग लीडरशिप है गुजरात में, हमारे मंत्री श्री और जो भी जेट को वगैरह सब हमेशा कार्यरत रहते हैं। तो मेरा कहना ये है, और दूसरा मोदी साहब का विजनरी मैं बता रहा हूँ कि कच्छ में जो गुजरात सब विजिट किया होगा, वहाँ सर पूरे दिन में एक बस जाती थी यहाँ से पूरे सेंट्रल गुजरात से कच्छ में, और कोई जाता नहीं था। ऐसी जगह पे उनने विजनरी खाली रख के ऐसा प्लान किया कि वहाँ अभी टिकट नहीं मिलता आपको जाने के लिए, इतनी भीड़ रहती है। तो मेरा ये रिक्वेस्ट है सर कि आप इस तरह से प्लानिंग करिए। अभी हम लोग स्ट्रगल कर रहे हैं कि हमको कनेक्टिविटी दीजिए। अभी मैं बा प्रेरणा में हूँ, सीनियर वाइस प्रेसिडेंट, तो हम डेली ये एसटीयू से स्ट्रगल करते हैं, सीटीयू से स्ट्रगल करते हैं कि हम लोग सीरियस प्लेयर है लेकिन हमको लोड नहीं है, डिमांड नहीं है, ये सब जवाब के कारण कनेक्टिविटी में दिक्कत हो रही है। तो इसका सर आपके पास कोई उचित जवाब है तो बताइए।
Thank you very much. So let us go in a slightly structured fashion. As you can see, my hands are full with the questions and the suggestions. So very quickly, I can put them in 2-3 buckets. एक तो है curtailment का इश्यू, दूसरा है कनेक्टिविटी का इश्यू। तो ये जो लास्ट स्लाइड थी ना इनकी, राठौड़ साहब की वाली स्लाइड दिखा दीजिएगा तो, या दैट्स इट, ठीक है इसी को। सो दीज आर द इश्यूज, एंड जितने क्वेश्चंस आए हैं इनको यदि मैं एकत्रित करके कुछ करने की चेष्टा करूं तो कुछ ऐसा दिखेगा। फिर हम क्वेश्चंस भी एक एक करके जल्दी जल्दी करेंगे, और मैं थोड़ा सा बोल के उस पर टच करूंगा, और यदि आप लोग में इसमें किसी को भी सप्लीमेंट करना है तो प्लीज फील फ्री। तो एक तो आई वॉज वेरी हैप्पी टू सी राठौड़ साहब के प्रेजेंटेशन में टीटीओ, मैं बता रहा हूँ ये माने इट इज सच अ प्लेजर, और पोरवाल साहब ने भी ये कहा। तो मैं एक थोड़ा नंबर के बारे में बोलता हूँ, हो सकता है मेरे नंबर गलत हो, मैं मोटे मोटे नंबर बता रहा हूँ। 2000 सबस्टेशन है आपके 66 केवी के, फिर 220, फिर 400, फिर 765 केवी, और रोज बन रहे हैं। रफली 1 लाख सर्किट किलोमीटर है गुजरात में, मोटा फिगर 1 लाख सर्किट। एटलीस्ट 2 लाख टावर है गुजरात में। नाउ इमेजिन 2 लाख टावर की कनेक्टिविटी जो है वो तो बनती रही, जैसे बनती गई। अब उसको यदि कोई ग्राफ थ्योरी लगा के ऑप्टिमाइज करे तो क्या ग्रिड बनती, ये है चैलेंज। मैंने बहुत सारे क्वेश्चंस में देखा, सीटीयू एसटीयू के इश्यूज बता रहे हैं, प्राइवेट सेक्टर की, एंड गुप्ता जी ने भी बताया कि कैसे हम इसको ऑप्टिमाइज करें। तो दिस इज वन एरिया वेयर सर्टेनली नाउ गुजरात इज इन अ पोजीशन टू डू समथिंग अबाउट इट, एंड वी मस्ट डू समथिंग अबाउट इट। लाइन तो बनानी ही है, कोई दो मत नहीं है, लेकिन इसी में देखा जाए कि इसको कैसे ऑप्टिमाइज किया जाए। क्या कोई पुरानी लाइन थी जो कि अब पर्पस कम सर्व कर रही है, उसको इस ढंग से घुमा दे। प्लानर करते हैं, प्लानर बहुत मेहनत करते हैं, लेकिन टावर बाय टावर करना, 2 लाख टावर का, हर का लॉन्गिट्यूड लैटिट्यूड पता है, उसको कैसे ऑप्टिमाइज करेंगे। अब इस पे मैं थोड़ा सा एक चीज बताऊं, एमआईटी में इस पे बहुत रिसर्च होता है, लेकिन यूएस बाकी कंट्रीज में इस ढंग से सीटीयू एसटीयू इस ढंग से डेवलप नहीं हुआ है। हम लोग के कंट्री में ये डेवलप हो गया। तो दिस वाज वन पॉइंट आई थॉट आई वुड मेंशन इट हियर, व्हिच विल आंसर मेनी ऑफ द क्वेरीज व्हिच यू ऑल हैव रेज्ड। दूसरा एक रेज किया गया है कि रैंपिंग का इश्यू है, कॉस्ट का इश्यू है, ये सब तो है ही। तो मोटा नंबर बताऊं, आपका 25 गीगावाट का लोड रफली, मोटा मोटा, और कितना कोयला जलाते हैं हर घंटे, मतलब कॉस्ट 2 करोड़ रुपया हर घंटे में, मोटा मोटा मेरे समझ से 2-1 करोड़ रुपया का हिसाब है। और लोड वेरी करता है, आरई वेरी करता है। अब इस दो, और कितने यूनिट्स हैं, 20 एक तो कोयले की यूनिट है, हाइड्रो है, गैस है, इंपोर्ट है। अब ये इतने सारे जनरेटर्स को वेरिंग लोड के साथ में कैसे किया जाए, वहीं प्रोफेसर जाकिर जो बता रहे थे कि इसको अभी हमें ऑप्टिमाइज करना पड़ेगा। ये हम सोचते थे कि हमें आता है, हम बता देंगे क्या होगा, वो नहीं चलेगा। अब हमको उसको सिस्टमैटिकली ऑप्टिमाइज करना पड़ेगा। एंड आई मस्ट से गुजरात इज वन ऑफ द लीडर्स। इन लोगों ने पायलट चला चुके हैं, और उससे हम लोग पूरा निचोड़ के एकदम ऑप्टिमाइज करेंगे ताकि मिनिमम पे ला सकें कॉस्ट को। दैट इज द पॉइंट हियर। सो आई थिंक दिस इज वन एरिया वेयर इट विल बी डन।
अभी आ जाते हैं जल्दी जल्दी बीएम शाह साहब के क्वेश्चन है। देखिए, इनका एक कहना है कि प्रोफेसर जाकिर के लिए कि एक शॉर्ट टर्म कोर्स कीजिए 3 to 4 months ताकि प्रैक्टिशनर्स को, आई थिंक ये तो बिल्कुल बेनाइन रिक्वेस्ट है, इट मस्ट बी डन। एंड कैपेसिटी बिल्डिंग आपने लास्ट में कंक्लूड किया, तो कैपेसिटी बिल्डिंग इज एब्सोल्युटली एसेंशियल और एक बार से नहीं होता है। कहते हैं ट्रेन देम डोंट ब्लेम देम। यदि आप ट्रेन नहीं कर रहे हो तो वो कैसे होगा? सो दिस इज अ वेरी वेरी वंडरफुल सजेशन। दूसरा उनका ये, बालन सर तो ये कहना चाह रहे हैं कि डीएसओ, बात तो सही कह रहे हैं आप, लेकिन डीएसओ का आइडिया आना पड़ेगा क्योंकि वो भी समय लगता है। इंस्टीट्यूशन बिल्डिंग टेक्स लॉट ऑफ टाइम। एसटीयू, एसएलडीसी, सीटीयू, ये सब इंस्टीट्यूशन बनाने में भी टाइम लगता है। तो आई थिंक दैट इज ऑल्सो वन ऑफ द सजेशन विच इज अ वेरी अंडरस्टैंडेबल थिंग। दूसरा टू सीटीयूआईएल का, अब ये पॉइंट है लेकिन आई थिंक बालन सर और अदर्स भी कहें, इनका कहना है कि जैसे प्लानिंग क्राइटेरिया आप बनाते हैं ट्रांसमिशन में, डिस्ट्रीब्यूशन में भी क्या प्लानिंग क्राइटेरिया क्या है? आई थिंक डिस्ट्रीब्यूशन के काफी डॉक्यूमेंट्स अभी आए हैं ऑफ लेट, आप उसमें देखिएगा। बट आई कंप्लीटली एग्री विद शाह साहब, वी हैव टू नाउ लर्न फ्रॉम डिस्ट्रीब्यूशन, ट्रांसमिशन हैज टू लर्न फ्रॉम डिस्ट्रीब्यूशन। डिस्ट्रीब्यूशन के जो लाइन्समैन होते हैं वो कैसे लाइन को चेंज करते हैं, कैसे ऑप्टिमाइज करते हैं, तो ट्रांसमिशन में भी उस ढंग से सोचना है, बट ट्रांसमिशन के भी क्राइटेरिया आना है। एक क्वेश्चन टू पोरवाल सर, इनका कहना है कि क्या हमें आरई जनरेटर्स के लिए, ग्रीन हाइड्रोजन के लिए, डेटा सेंटर के लिए क्या अलग ग्रिड कोड बनाना चाहिए? तो पोरवाल साहब अपना व्यक्त रखेंगे, लेकिन ये सब्जेक्ट बहुत बार आता है। पॉइंट ये है कि ग्रिड है, ये तो बदलती रहेगी, कल ये है, परसों ये है, हर का अलग अलग कोड बनने से मेरे समझ से वो नहीं होगा, क्योंकि सब एक साथ काम करते हैं। लेकिन पूर्वल साहब कुछ बोलना चाहेंगे?
सर, जो आपने बोला बिल्कुल ठीक कहा कि ग्रिड कोड तो एक होगा, उसके बीच में कैसे एक दूसरे के बीच में तारतम्य भी रहेगा, तभी वो सही ढंग से काम कर पाएंगे। हमको जैसे बोलना है कि जो भी थर्मल के लिए कुछ रूल्स हैं, आरी के लिए कुछ दूसरे रूल्स हैं, बट एक ही कोड में रहेंगे एंड देयर हैज टू बी यूनिफॉर्मिटी, सो दैट अभी कल को मान लीजिए आपने एक दूसरा ग्रिड कोड बना दिया, तो उसमें क्या लोग कहेंगे इसमें ये चीज़ लिखा हुआ है, इसमें ये चीज़ लिखा हुआ है, इसी में कंफ्यूजन हो जाता है। देन वी आर इन नो वेयर कि करना क्या है एक्चुअली, फाइनली नाइदर टू द जो डेवलपर हैं या यूजर्स हैं उनके लिए भी, और जो आरएडीसी एसएलडीसी में जो लोग हैं, एसटीओ सीटी में है, उनके लिए भी प्रॉब्लम है भाई करना क्या है। इसलिए कोड एक ही होना चाहिए, इसमें सेक्शन अलग हो सकते हैं, कुछ चीज़ें डिफरेंट चीज़ के, जैसे आज भी हम लोग कहते हैं कि आरी इज ए मस्ट रन, वो मस्ट रन रहेगा कि नहीं रहेगा वो अलग चीज़ है, वो एक अलग डिबेट है, बट वो सेम कोड में वो सारी चीज़ें आ सकती हैं कि भाई इसके लिए ये चीज़ आपको देना है। जैसे मान लीजिए छोटी सी चीज़ देखते हैं कि जो ट्रायल रन ऑपरेशन है, हो सकता है थर्मल के लिए 6 महीने का टाइम है, इसके लिए आरी के लिए 15 दिन का टाइम है, तो इस तरह की चीज़ें डिफरेंट रहेंगी, बट दे हैव टू, यूनिफॉर्मिटी रहेगा, हार्मोनाइजेशन रहेगा अगर एक कोड में।
थैंक यू। अच्छा, कई क्वेश्चंस हैं वोल्टेज को लेके, जो कि हमारे पैनलिस्ट लोगों ने भी कहा कि रिएक्टिव पावर एंड वोल्टेज इज अ सीरियस इश्यू। विथ आईबीआर वी कैन डू लॉट ऑफ थिंग्स ऑन द रिएक्टिव पावर एंड वोल्टेज। तो शैलेश जी जो गेटको के हैं, उनका भी कहना है कि हमारे को तो लो वोल्टेज हो जाता है, तो हम क्या करें? एक चीज तो जरूर है, हमको आरई को मैक्सिमम एब्जॉर्व करना है, और डिमांड को हम जल्दी से डिस्टर्ब नहीं कर सकते हैं, डिमांड रिस्पॉन्स, तो हमें रिएक्टिव पावर के साइड में काम करना है। आई थिंक दिस इज अ वेरी स्ट्रेट फॉरवर्ड सजेशन है, लेकिन यस, दिस इज अ चैलेंज बिफोर अस, और ये बढ़ेगा, जितना रिएक्टिव पावर आएगा उतना बढ़ेगा। हाँ, बताओ बताओ।
जो डिस्ट्रीब्यूटेड रिसोर्सेज आ रहे हैं,
हाँ,
अभी दिस इज द राइट टाइम, वी मस्ट हैव सर्टेन थिंग्स, मैन्युफैक्चरर को अभी आज की डेट में मैंडेट करना होगा कि आपको ये रिएक्टिव पावर इस तरह से चलेगा, क्योंकि हर कोई वहाँ पे चेंज करने नहीं जाएगा। जो रूफटॉप पे लग गया घर में, कोई भी चेंज नहीं करेगा, बट इट इज प्रोग्राम फ्रॉम द इनिशियल डेज कि आपको रिएक्टिव पावर चेंज करना है, वोल्टेज के अनुसार वेरी करना है, तो दिस दे विल कीप ऑन डूइंग दैट। दिस इज द राइट टाइम, क्योंकि ऑलरेडी बहुत सारा रूफटॉप आ गया है, आगे और आएगा, तो अभी इसी समय अगर इस चीज़ को मैंडेट कर दिया जाए कि इस तरह से मैन्युफैक्चरिंग हो, दिस विल बी अ गुड थिंग।
एब्सोल्युटली।
एज फार एज ट्रांसमिशन वगैरह में एक और चीज़ है, डिस्ट्रीब्यूशन में जो अभी हमारा एसी का लोड बहुत सारा बढ़ रहा है, 17 जून 2024 में एक इवेंट हुआ था नॉर्दर्न रीजन में, जिसमें कि बहुत सारा से 60 गीगावाट वेंट आउट ऑफ द सिस्टम। लोड कहीं नहीं गया, बट आपको लगा ऐसा कि 62 गीगावाट अभी सिस्टम में नहीं, तो फ्रिक्वेंसी बढ़ गया, वो सब हुआ। इसके लिए भी हमको प्लान करना चाहिए, इसका जो मॉडल है लोड का उसको देखना है सही ढंग से, और क्या चीज़ें हम जो डायनेमिक रिएक्टिव पावर सपोर्ट चाहिए। मतलब अभी तक हम केवल कहते थे स्टैटिक, कुछ जगह पर हमने कैपेसिटर लगा लिया, कुछ जगह पर रिएक्टर लगाए हुए हैं, बट डायनेमिकली कैसे हम रिएक्टिव पावर को सपोर्ट कर सकते हैं, दैट ऑल्सो नीड वेरी नीड ऑफ पावर distribution at the transmission level. This is it.
Absolutely important, and I'm sure Mr. Balan is taking note of it. I know, sir.
Sir,
So,
I-
yeah, so CA has
just
to,
a minute,
yeah,
sir.
please.
What Purvals have said, that whatever rooftop and all those things we are putting up, there should be some criteria for development of those things. Like, I'm giving another example for vehicles. The government is making BS standards, BS4, BS5 and all those things. So since that is a bit organized sector, so that is being implemented. But in electrical, I mean, like rooftop and all that, many developers are there. So this is Balan Saab's responsibility, I think, that they should frame up the standards and should be enforced. Because enforcing those standards at rooftop is very difficult. So enforcement has to be from the states, discoms.
So
that is very important.
absolutely, standards. The industry runs where the standards run. So standards are absolutely important. If you want to tame the industry, then standards are the one, and industry has to get into the standard. There is absolutely no issues at all on this. And there are some other questions. Let me put it like this: R&D is an issue, and the point which is made is, of course, it is very futuristic, but for example, can we have wireless power transmission? Yes, those are all things which Professor Zakir said that we work for 30-40 years in advance, and there are other things. But yeah, if anything you would like to add here.
So before answering this wireless power transmission, I just like to touch upon the earlier 2 points. The grid code regulations that was being mentioned, which Parvali also mentioned to some extent. See, this grid connection regulation is very critical. We have been analyzing, studying, investigating grid code regulation across the world. In my opinion, we in India are not as active as we should have been in framing the adequate grid code regulations. I think we are lagging for whatever reason. There might be hundreds of reasons. I am not actually going into that, but I'm just trying to mention the fact when we analyze the grid code regulations, connection regulations across the world and in our country, we are lagging behind in framing, coming up, designing the adequate grid code regulations, and equally, or if not equally to a reasonable extent, in effective implementation of those regulations. That is the one observation that I have. Second is related to this grid code regulation for storage, other things. Should we have separate or whatever? Separate can be there. I mean, that's fine, but it will be a single kind of document that is going to be there. For example, storage is already there. It is already being put up in several parts of the country, though right now predominantly at the distribution system. Electrolyzers are coming. Data centers are already coming. Do we have grid connectivity standards for them? Even at some stage, at this moment, no, we do not have. There are many countries, for example, Denmark, Germany, which have already come up with a detailed set of regulations, grid connection regulations for storage, for electrolyzers, for data centers, for electric vehicles, very detailed. So therefore, because now the thing is that we will experience issues later and then we'll come up with some regulations, is something which we need to actually focus on and be proactive in coming up with those adequate regulations. Second is a dynamic reactive power, which is reactive power thing, which is being mentioned very often. There are two approaches that the world, those countries, particularly RE-rich countries, have adopted for this reactive power issue. We were working for 2040 grid of Danish grid planning, precise planning, so much clarity with the planning department of the transmission system operator over there with 2040. So we're working on different aspects. One of them was this reactive power support. We came up with a detailed optimal solution for reactive power support, dynamic and static. And in dynamic, we came up with the proportion of different proportion of synchronous condensers, statcoms, and other sources. Our proposal was detailed, and then it was analyzed by their planning department. They decided to go ahead with the synchronous condenser because our solution proposal was also mentioning 70% of the compensation from synchronous condensers. They went ahead with the synchronous condensers only, and a lot of synchronous condensers are already in place right now in their country. That is one approach. You put infrastructure for the reactive power. There is another approach, that is market-based approach. Republic of Ireland, the two Irelands, Northern and Ireland. Ireland has adopted a market-based approach. They came up with an ancillary product of dynamic reactive power. Now they are procuring that from the market, dynamic reactive power. So therefore, one thing is there has to be a clear direction at the system level, policy level to be taken. Should it be infrastructure based, that the utility will put the infrastructure itself and then use it for the this asset for the reactive power, or there can be, of course, we are still not that mature in the market side, but these are the two ways approaches that the world has approached. One is market based approach, second is the infrastructure deployed by the transmission utility. Now coming to wireless power transmission, this has been experimented hundreds of years back, this wireless power transfer, and there have been several further attempts over the time. But there are several challenges associated with this. I'll just limit to a couple of them. One is to transmit power through the wireless. I mean, wireless at a small scale level, we already are experiencing, right? We have the chargers for mobiles. Wireless chargers are already coming for electric vehicles. So at that scale, it is there. But if you are asking the wireless transmission of the power of our power system, then there are several challenges with that. One of the major challenges is to generate that extremely high voltage to ionize the medium of transmission, wireless transmission, air or whichever we want, and then maintain that. And the second most important is the efficiency is low. And equally third important is the safety. With a lot of electromagnetics that is going to come along with this wireless transmission, how much is going to impact the society? How much is going to impact the communication infrastructure? So those challenges are there. At this stage, based on my understanding, we don't see that wireless power at a large scale is right now an option which will actually, compete with the existing connected based transmission. Thank you.
Thank you very much. If you read Tesla, Tesla has tested, and since then it is going on, and we heard that it is not something which will happen very shortly. So we move to the other things, other questions. Gujarat, what is the strength? The strength is coastline, 2,340 kilometers. Offshore wind is coming. And again, I think all the panelists are emphasizing that standards have to come. We should not be lagging, and we are slow in that. And once the critical mass gets connected, then changing the standards becomes very, very difficult. So I think that is one of the things which Mr. Hartik was mentioning, that how do we go about offshore wind. So that's one. Now, let's very quickly come to that. IBR has been raised by many. I think Professor Zakir mentioned it again and again. There again, the question is of standard, but grid forming capability of IBR, and the model of that, and associated inertia issues. I think this is also a very important one. Professor Zakir will again come back to this. I am holding it because it's a favorite topic of yours and we need it. We will come back to that. Next is
CTU STU coordination. It is from Mr. Jitendra Joshi, Reliance Industries. So that's another area which will always be there the moment multiplicity of organizations are there. But I would say still, CTU STU are coordinating pretty well. But there is anything you would like to say? Yeah.
Hello. Well, so I think as far as coordination between CTU and STU goes, uh, I don't know whether it is known to the audience or not, but regularly we are holding meetings between the CTU, then state electricity boards or STUs, and also we are associating CA in those studies, and wherever required, Grid India is also associated in those studies. So even जब STU का सिस्टम बनता है तब भी CTU उसमें सपोर्ट करता है, और जब CTU का सिस्टम बनता है तो then we take inputs from STU as well. So it's always a joint kind of the effort where we collaborate both CTU and STU and take support of CA, take support of Grid India, and then plan the system. So it's not in isolation. It's always planned in association with CTU, STU, CA, and Grid India.
Thank you. Thank you. I think, yeah, please, please.
CTU, STU coordination, what KK has said is perfectly all right, that they discuss, they plan together. But earlier some thought was going on that there should not be two networks, ISTS and intrastate. States should look at certain level, say below 132 kV, and ISTS should look up to 220 kV. Here the question is, at many places there are parallel lines. ISTS 765 kV network and intrastate 220 400 kV network, and sometimes those lines are totally offloaded because the parallel circuits are there. So the coordination means actually there should be a single plan, and then in the plan you should tick this line will be made by STU, this will be made by CTU, and this will be done under the DISCOM system. So that kind of planning is needed now in the country with a lot of RE being integrated. So that kind of planning is required. I think in future it may come. Then it will optimize the way you wanted in your transmission topography, that where CTU and STU should work together.
Yeah. I think as a technical, we are all in agreement that it has to be further optimized, but there are much bigger issues. Ministry once gave an order that all 33 kV should come to transmission. Below that only should be distribution, then it can be better optimized. But then it is a jurisdiction issue, it's a question of tariff issue, the legality of site. But I completely agree that if we have to keep on moving with this 500 gigawatt RE, then this kind of a fragmentation cannot give us an optimum solution. Some major challenge is required, and that is probably take us to a much more policy at a very high level issues. But I think we agree to this. Okay. There is another full set of question on green hydrogen. BESS versus hydrogen. I'll park this for some panelists to come back again. Now, the other point is flexibility in generation, banking, then there are all the issues, curtailment, all these issues are with respect to dispatch. Very important. And this will keep on changing. So the solution which appears is that we spell our problems, which are constraints, and then run an optimization, because that is the best thing to do, honoring constraints and get the best thing. I think that we have already discussed, but this is an issue. But flexibility is going to be the most prized commodity down the line. Everywhere the flexibility has to be brought in. But then flexibility, by just saying flexibility doesn't come. It has to be incentivized. You have to pay for it, how much flexibility you want. And that's where the shadow prices and other things will come through SCED, which already Gujarat has started with this. Okay.
Now there are some questions. I think these are best discussed offline. But the question is that the standalone ESS is an issue which recently has come. So the question is uh, that all ESS shall be with RE source. So why is it technically required is a kind of a question. If any of you would like to answer quickly, but I know that it can start a full day debate and still we will not be reaching to the solution, but still something on this.
Basically, we need to think about ESS as again a resource. This can come at transmission level also. This can come at distribution level. This can come as a with generation. So why we are saying, people are saying that it is co-located. You need to be co-located because you need slightly less transmission in that case. So that is one use case. So that is coming with transmission. If it is a standalone, so it will need somewhere to get it power from somewhere, whether it is conventional or whether it is RE also. So again, this has to transmit power from this location to this location. So you need transmission also. If it is for it is a distribution, so entire transmission and distribution network it is utilizing. But there may be different use cases. Say if it is a distribution level, daytime there is not, say, suppose that not much load is there. There is a margin available in the transformation capacity. You put storage as a distribution level, and then evening time it will, when your load, lighting load, etc. goes up, during that time you can supply from this storage. So again, based on, it is not that we have to only go for the storage with, along with the generation, or we there need not be any standalone storage. Everything has to come, and based on situation to situation. So it is not that we again, as Soni Saab has said, that okay, let us optimize that, whether it is a good point to install a standalone storage, or whether it is good to have with generation, or whether it is good to have at distribution level.
Yeah.
I just want to add
Yeah.
one or two sentences. देखिए, जैसे आरी का पेनिट्रेशन बढ़ा और खासकर सोलर जनरेशन जैसे जैसे बढ़ा, तो उसके लिए मैचिंग ट्रांसमिशन सिस्टम की ज़रूरत हुई। तो जहाँ पे सोलर जनरेशन बढ़ा, उसको एवेक्यूएट करने के लिए ट्रांसमिशन सिस्टम बनाया गया। नाउ गोइंग फॉरवर्ड, इट वाज इट वाज फेल्ट दैट जो सिस्टम बनाया गया उसमें सोलर पावर जो है वो डे आवर्स में तो सोलर पावर आ रही है, बट ऑफ सोलर आवर्स में वो ट्रांसमिशन सिस्टम खाली है। तो देन दी थॉट केम कि क्यों ना इस ट्रांसमिशन सिस्टम को हम ऑफ सोलर आवर में भी यूज कर पाएँ। और उसको यूज करने का क्या तरीका था कि आप उस डे आवर्स में सोलर पावर को बैटरी में रखिए और उस बैटरी की पावर को फिर रात में निकालिए। अब इसके लिए दिन के लिए तो आपके पास ऑलरेडी जनरेशन है, सोलर जनरेशन ऑलरेडी अवेलेबल है। तो देन द कॉन्सेप्ट केम कि वहाँ पे आप सोलर भी लगाइए, एडिशनल सोलर लगाइए, और उस एडिशनल सोलर से आप बैटरी को चार्ज करिए, और उस बैटरी से आप रात में जो आपका ट्रांसमिशन सिस्टम ऑलरेडी बना हुआ है, उस ट्रांसमिशन सिस्टम को यूज करते हुए बैटरी में स्टोर्ड पावर को इवैक्यूएट करिए। सो दैट वाज द पर्पस कि आप कैसे ट्रांसमिशन सिस्टम जो बना हुआ है उसको ऑप्टिमली यूटिलाइज कर सकें। बट ऑफ कोर्स दिस इज द इवॉल्विंग काइंड ऑफ टॉपिक, एंड जैसे जैसे चीज़ें आगे बढ़ रही हैं और फर्दर एवोल्यूशन इसमें हो रहे हैं, so going forward we will see some more improvements and discussions in this.
And see, there is no perfect solution. The whole world is struggling with this. Where do we get what kind of a resource? And the second is, how do we utilize it? The jurisdiction changes, the regulatory regime changes, the organization changes. So how do we get it is a challenge. And other than technical, it has regulatory and policy changes. We can't have it. See, for example, the two states, you just cross the states, everything changes, the different taxes change. So these are a much bigger issue, but yes, that's an issue. But still, in power system, we are able to do. Some few very good questions. I don't know what the answer would be, but let me flag. Solar generation 1 megawatt requires 4 to 5 acres of land. The impact on agriculture. So this is the power water nexus and the land issues. These are very serious issues, but I am sure the technology is gradually helping us in miniaturizing the thing to the extent possible. But yes, but India is very blessed. Our west side, which was barren land and not much of a use, we are able to make use of it, at least that. Anybody would like to add very quickly on this? But otherwise,
So
yeah.
I'll just add into this. First of all, the large scale RE parks are coming in the barren land. So there's no problem, Khavda and Bikaner complex. But when someone said ki 1 megawatt requires 4 to 5 megawatt, 4 to 5 acres of land, now the concept of agrivoltaics is taking place in our country also, where in your farm, if you have 2 acres of land, you can generate 1 megawatt electricity without any problem, and farming yield increases to almost twofolds. And that too, the crop is a cash crop. If you are cultivating rice, wheat, no, you cultivate broccolis, you cultivate capsicum, colored one, and get more money and give health to the people. So there is absolutely no problem. On agricultural field also, we should go for the generation through agrivoltaics.
Yeah, on
Government is giving a lot of incentive.
Exactly.
Only thing, the panel has to be raised to around 5 meters so the tractor can run underneath.
So like in any work, this agrivoltaic, at least for last 5 years, I know Dayalbagh Engineering College had a full project. You can go, whether the tractor can also go. So there are issues, and but we are now able to optimize both things. It's possible. Yeah. Yeah. There are many. There are many of
only
these things.
one point from
please.
Only from the system security point of view, we'll keep on moving only to Rajasthan and say Khavda area of Gujarat. From system security point of view, it is very will become more and more challenging.
Yeah.
And therefore, there is a requirement that we need to spread it out at different places, different areas. And this agri, say, photovoltaic definitely is a one innovation, and we keep on innovating. We need not to say that only the 40 years down the line the research will be fruitful, but we keep on every day, and each of area, each work, we need to keep on innovating.
I think we are running out of time. Yeah, one point which is I'll just flag and then you can supplement there. Yeah. So I'll just cover this, then we'll again. There is one series of questions which are being raised is on the regulations, and certainly the regulations and standards have to have the same pace as technology and the targets which are changing. That is one part. The other part which is coming is the data part of it. Very rightly flagged by anonymous person who has sent this, that data is becoming an issue, whether it is real-time data or offline data or model data. And I am sure that the policymakers are working on it, that India Energy Stack, we keep on meeting and say that India needs a full-fledged regulation and a policy on data. And we hope that it will come soon. So, yes, please, now I think we can, yes, please, yeah.
Good afternoon, sir. My name is Anil Bhatia. I am from Singapore. We do offshore wind transmission in various countries, Korea, Taiwan, and so on. So, Professor Dr. Zakir's subject of. So, I just wanted to add something for the audience, that is inertia. The inertia of the grid is very important. Spanish grid had recently collapsed, and that was basically inertia. So, condensers, rotating condensers are definitely important for as we go penetration higher, we will need condensers. Second is offshore wind, and all these batteries and cars and all, they are adding harmonics. So STATCOMs are very important. The thumb rule in the world is 500 megawatt of offshore wind, 350 to 400 megawatt MVR of STATCOM. That is the thumb rule now. So grid compliance, grid code, really important. Otherwise, we will end up in a big grid.
Yeah.
Inertia as well as harmonics. Harmonics is very important.
Thank you. See, this conversion of old units, repurposing them to synchronous condensers, lot of work was done in India. So I am sure that the policymakers are thinking on it. But you know, when it really comes to ground realities, land is an issue. The old power plants are in a very precious land. So those are there, but point very well taken that we need dynamic reactive power. And that can come through synchronous condenser, as Professor Zakir mentioned, or through STATCOMs. But then again, a question of investment and optimization. But I am sure planners and policymakers are thinking over it. Anybody else has any other questions in mind immediately? Otherwise, thank you very much. You all have been a very nice audience, and we have tried to answer queries. But I am taking all these back. We will try to compile and give it to the organizers. That these are the queries and these are the problems. Thank you very much. Oh, Mr. Balan has to conclude. Hey, I am so sorry. I am sorry. Please.
Namaskar, sir. The topology, first question, topology you are talking about, 1 lakh towers, 2 lakh towers are there. How to optimize these things? See, in the case of islanding is there. When you design the islanding schemes for any grid, we first disconnect the RE sources. They are not dispatchable. Gujarat is having 2047, 90% RE. So how we are going to have the islanding schemes? So unless it is dispatchable with storage, you cannot have the islanding schemes for meeting the grid disturbances. This is a serious issue. How to plan for that? Ramping, okay, I don't know any answer for that. And capacity building we discussed. DSO, distributed system operator. This already we are working on that. She already prepared the planning criteria for distribution in addition to transmission. This is also in the public domain. Please download and read also. This is all given there. Then data center. Data center, we had a lot of meeting. Next week also one meeting is there. Many clients, mostly they want near Mumbai, Pune, Hyderabad, Bangalore, Chennai. Why? Their landing stations are there in Mumbai area, most landing stations, and Chennai something is there. And we urge them to move to Kavda, Gujarat, and Rajasthan also. Where RE stations plants are there, they are unwilling to move. Their supply reliability and also other data cable communication availability. So this and all they are asking, and also cooling water also maybe needs cooling water also. So these are the issues now. They are reluctant to move to the RE rich areas. And one more, then 6 months, okay, this was voltage, IBR sources issue. See, when I was in RPC, we conduct a lot of meetings for voltage management, DRT for management. See, many states, for example, some states are having some norms. Up to 200 kV, below 200 kilometer length of the line only, I will put reactor. Till then, I won't put reactor. Who will absorb the power? Even now, each region, 30-40 lines are kept switched off to contain the over voltage now. So many states, they have that norms also. Unless you revise the norms, even though they have bus reactor, but unless you absorb the voltage in the zone, you cannot do anything. That neighboring zone. Yes, this is important now. So we have proper policy and in my opinion, transmission, distribution, generation, the transmission, there should be zero Q flow. If you adjust, if you plan that way, then this issue may be contained. Then rooftop solar, I already told you that the ministry is asking us to devise a scheme how to measure the generation of the behind the meter rooftop solar in real time. That we are working on that. R&D is an issue. Wireless power transmission already they told, and grid code. Then data centers, I already told you what is the industry requirement. Data supply also, and this wireless transmission standards. Offshore wind, you asking offshore wind. We already prepared the regulations. It is in the final stages. Soon will be released also. On offshore wind, we had tough time to get the standards. So I spent so much time to read the offshore wind document. The technology is very complex technology. So 45,000 tons of weight you would lift. Where you have the grain, ships, piling, and array cable, export cable, offshore substation. If the depth is above 100 meter, then go for floating substation. So technology is challenging only. India, I don't think the technology is available there immediately. So we have to wait for that, and I think it is being done. And standards, you are talking about standards. See, in general, how are standards being made? Correct? How to make a standards now? Can we have standards for the moon landing? Why? No standard for moon landing, no? So the generally standards how they make, I introduce a concept or method. So over the time it becomes popular, correct? No? Introduce, becomes popular, more people adopt. After some time it become de facto standard. Then after some time becomes standard. These are the standards of standard. These are stages of standard now. Unless you follow this by the introduction and use it and make it popular, then make it default standard, de facto standard, then go to standard. So bypassing everything, suddenly go to standard may not be suitable for system. Our technology may fail also. This is my view. And IPR sources earlier given that, then the storage classes. Storage is very important. One more thing about storage now. Please, storage is having lot of use cases, correct? Islanding, black start is there, on energy arbitrage or peak saving. So many applications are there. The cell and modular all are having the C rate. C rate is there. So unless you design the C rate first time itself, that you can't use it for say for example short term cell cannot be used for long term storage. So C rate will decide your application of the battery. So that you will be very careful. So at design time itself, how do you want to use your battery? This is very important. Storage is there, and CTST coordination. This also I want to highlight. This is a very complex issue, and I've speaking in the RPCs. Sometimes we have to mediate between Genco and Transco. This is a fact. Many states, Genco, Transco, not much cooperation, or even not even communication also. Many states. So we have to intervene and we have to unite them, and similarly Transco and Discom also for the load forecasting, transmission planning. There should be a coordination. This is administration missing. It should improve so that system will be benefiting. Thank you, sir.
Thank you very much. Thank you very much. I think this brings us to the conclusion. Thank you.
I sincerely thank you to the moderator and all the panelists for such a wonderful and insightful session. Hope you all have learned something from this informative session.
We have memento for our moderator and panelists. For that, I would like to request Sri P.N. Patel sir, Superintending Engineer Navsari JETCO, to present the memento to S.K. Suni sir. Please, sir. S.K. Suni sir, Senior Advisor, CEA. Moving next, Sri P.G. Garg sir, Principal Advisor, NSEFI, former COO, CTUIL. Moving next, Sri Rajiv Powal sir, Director, System Operation, Grid India, NLDC. Moving next, Sri A. Balan sir, Member of CEA, Planning. Dr. Zakir Hussain Rather sir, Professor, IIT Mumbai. Big round of applause for all. Sri Kailash Kumar Gupta sir, Chief Operating Officer, CTUIL. Thank you so much, sir. Coming toward the end of this session, I would like to request Sri P.N. Patel sir, Superintending Engineer, JETCO Navsari, for giving vote of thanks. Sri P.N. Patel sir.
Thank you very much, sir. Today we are learning this session, and we are very grateful to honor all dignitaries, respected dignitaries, ladies and gentlemen. We began this morning with a vision, a green energy for the Viksit Bharat 2047. After the huge minutes. We have learned this session. Three takeaway from the today: plan smart, invest, collaborate. The Gujarat grid be the backbone of the India Green Translation and STU and SLDC. I thankful to Honorable Chief Minister, MOP, MNERE, JETCO, and all delegates. Your ideas will directly shape our next step. Thank you for the beginning. Let's the meet again on the grid. Jai Bharat, Jai Jai Garib Gujarat.